it just it was introduced by its neighbor in, I think 1965, I'm not sure. I think I first heard about it in an article in the ASEAN, the communications of the ASEAN in '72, and it seemed too complicated. So I thought that there must be some solution, and I thought I had a simple solution. Pointing at the bug in my algorithm taught me that concurrent algorithms are hard to get right, and you really need to be careful and you need to write a proof that they're right. And it inspired me to say, damn it, I'm going to solve this problem. And I didn't came up with the paper. Hello?
Yes. Sorry.
Yeah, we are suffering a little bit against the boundaries problem. So one thing we can do, Leslie, maybe you can switch your video off. Maybe you're going to gain a little bit of boundaries, because sometimes you come well, but other time we don't hear you.
Oh, okay.
Just put the video off. Okay, great. Maybe that's going to improve. Sorry for that.
I hope so. How much of what I said could people hear?
Well, I heard about the genesis of your work on the bakery algorithm by being inspired by having read some paper on communication with ASEAN.
Okay.
I think. Did I get
so
that?
Okay, it sounds like you got the gist of what I had to say. Or did the part about coding versus programming come through?
Yeah, that we also got it, and I like the metaphor that coding is like typewriting to handwriting. It's a nice metaphor. I like it.
Okay, so I think you heard most of what I had to say. Is the copy through better now that the video was off?
Yes.
Yeah, I think so.
Good.
And one of the biggest challenges in computer science field is the need of constantly updating the skills and the knowledge. The field is constantly changing with new technologies and techniques emerging all the time. What do you think about is likely to be the most promising part of the computer science in the future?
I am no better at predicting the future than other people, and so I think that's not something I do. So I don't answer that kind of question.
Okay, no worries. And talking about 2013 Turing Award, which you received for the fundamental contributions to the theory of practice of distributed and concurrent systems, particularly the invention of concepts such as causality and logical clocks, safety and witness, replicated state machines, and sequential consistency. You devise important algorithms and develop formal modeling and verification protocols that improve the quality of distributed systems. These contributions have resulted in improved correctness, performance, and reliability of computer systems. Could you tell us how do you get interested in this particular area?
Well, happened is that someone, a couple of people wrote a paper on, let's see, maintaining a distributed database, where the problem is we have copies of the data, on different machines, and you have multiple users accessing that information. And they had a particular algorithm for doing that. And I realized that there was a problem with their algorithm in that it would violate causality. That is, one person, well, for example, one person could do an operation, deposit money in a bank account, and phone somebody else and say, okay, I deposited the money, now you can withdraw it. And the other person could then try to do an operation on that database and discover that his operation was ordered before his withdrawal was ordered before the deposit, and therefore the withdrawal failed. So I corrected that problem, but in correcting the problem, I had to state clearly what the problem was and what the nature of causality was in a distributed system. And people found that quite useful.
Okay. And talking about big data, currently people use machine learning to produce models. It was born from the pattern recognition and the theory that computers can learn without being programmed to perform specific tasks. Researchers interested in artificial intelligence wanted to see if computers can learn from data. This is in contrast with the analytical models in mathematics, which comes from the equation, then prove it using analytical until we derive the solutions. What do you think about it?
Well, I think there's a serious problem. The problem is that AI solves problems that we don't understand how to solve by essentially producing programs that we don't understand how they work. And since we don't understand how they work, we can't really say exactly what they're going to do, or exactly what properties they have. And this is a problem. I mean, you want to be able to make sure that your self-driving car doesn't go through a red light. But if you don't know exactly what its algorithm is for stopping, how can you prove that it's not going to go through a red light? I see that AI as sort of two ways it can be used. One way is the way it seems to be mostly being used is, somebody wants the computer to do something, so he says it in natural language, and it's ambiguous, and he doesn't understand exactly what it's supposed to do, and the AI program is going to do something that approximates what he thinks, what it thinks he said, and you're going to get a program that will sort of do something and maybe work fine lots of times, and sometimes do things that are ridiculous, and sometimes do things dangerous, and who knows. the other possible use is that the problem is that there's a, that the engineers that I deal with or have dealt with have to solve is they can write a very precise specification of what they want the computer to do. But that specification is at too high a level to be able to automatically be compiled into code. And the hope is that AI will be able to learn how to take that precise specification and compile it into code that does precisely what it's supposed to do. I'm afraid that the first model is the one that's going to be mostly used, but I hope that for applications where you really need things to be done right, especially where there's safety critical systems, that the second approach will be the one that's adopted.
Yeah, Leslie, I like your analysis that I must say I really share very much. And I'm also worried like you that the first approach, basically you you describe your problem and you let kind of a black box approach. So a system will basically try to implement what you're asking, but in a way which is not demonstrable correct. So for somebody like you who spent a good fraction of your life, demonstrating correctness of programs, it must be a great worry realization that is actually the mainstream. The mainstream, I mean, people go on ChatGPT and they get something which is plausible and often accurate 75%, but then it goes out of the tangent in completely hallucinating code. And that is worrisome, but for as long as you chop it for, let's say, entertainment or non-mission critical application, well, let's see, then it will get better and better. Now we know the latest Google announcement of more generative AI, same will improve, like has been the case in computer science. The second one, I agree with you, is the most interesting one. So where basically the implementation is really driven by engineers, so they specify the very high level, and then the system can be trained to implement that down at the level which the machine are able to execute, but somehow in a way which is still fully understandable. So we can also use in mission critical application. The example of autonomous driven vehicles that goes across a traffic light, I think is a perfect example where we cannot really just trust, a generic system, to do the work and hope that it's going to work, 99% of the time, because then 1% of the time it might kill people. Okay, I think at least on that we do agree, and thank you for this very, illuminating guidance. Okay, let's go on.
And how do you find the problems to be solved? For example, in the latex at the time, what problem do you want to solve by using latex, and how it deals with the latex?
It's about decided to for my book, and I managed to it and make them useful by other people. It's a little bit more work than I anticipated, but not a whole lot more. And that's how LaTeX came to be.
And Leslie, can you start again, because we didn't get the first part of the phrase. Sorry, we seem to have intermittent boundaries program. Maybe this time is our time. Can you repeat, sorry?
Sure. I said I was planning to write a book, and I decided that I would typeset it with tech, and so I needed to write some tech macros so that I could use to produce the book, and I figured that with a little bit of extra effort, I could make those macros useful by everyone. And it grew a little bit more than I expected, but not an awful lot of work. And so that's what happened, and people are using it. And I never did write that book, but that had nothing to do with LaTeX.
Thank you. And your work on the bakery algorithm use loop freedom concept, which is using the bakery analogy. For example, when we arrive to an empty bakery and being asked to wait for a customer who hasn't arrived at the bakery yet, loop freedom represents the ability of process to make progress independent of the speed of the other process. And as the bakery algorithm assigns turns to process in the order of their arrival, it has loop freedom. This is crucial concept, which has been used in the design of many subsequent algorithms and in the design of memory architectures. How do you implement a bakery algorithm in the design of memory architectures?
Well, the bakery algorithm is interesting for theoretical reasons, and mainly that it was the first mutual exclusion algorithm that didn't depend on somebody at the lower level solving mutual exclusion. But it's not practical for for mutual exclusion nowadays. People, in those days, when Dijkstra proposed the problems, there were no machine instructions to help it. He had to just do it with reads and writes, and that's what the problem was. But very soon afterwards, it was obvious that mutual exclusion was going to be very important and needed good, efficient solutions. And so the hardware designers built machine instructions that would make it much more efficient to do than any algorithm like the bakery algorithm that just depends on reads and writes.
And in one of your interview, I see that you like working in the industrial research lab because of the input, and you also like to work in the real world problems. For example, like Byzantine generals Paxos, they also come from the real problems. Could you tell us what kind of real problems that motivate you to do the Byzantine generals Paxos?
Well, Byzantine agreement built that, well, the Byzantine problem and the way it was phrased was that was done at SRI before I arrived there, although I was responsible for the name, but they had the problem, and the reason they had the problem was that they were building a contract from NASA to build a computer system that could fly an airplane, which meant it had to be very reliable, and so it had to tolerate all kinds of faults. but I solved that problem before I got to SRI in a somewhat different context, and not stated as concisely and as neatly as they did at SRI, but that was, well, if you go to my time clocks paper, the one that we discussed before, it gives a method for, general method for implementing any kind of distributed system. But it did not tolerate faults. And so the next problem that the next step, fairly clear next step, was to have an algorithm that could do what it did, but also tolerate failures, tolerate faults. And at that time, it was not clear what kind of faults. I mean, distributed systems were mostly theory more rather than practice. And it was not clear what kind of faults the system needed to solve. And therefore, I just decided that, well, I would let it handle, any kinds of faults. And the worst kind of faults is when a failed computer can do absolutely anything, including acting maliciously. So that's why I had, what we now call Byzantine agreement in that algorithm. Paxos came about because it was, let's see what the date was. It was, I think it was around 1990. And the Byzantine generals was in the late 70s. And by 1990, it was clear that the problems will be most common in distributed systems were what's called crash failures. A computer fails not by doing arbitrary things, but by just dying. So that was the type of error that one needed to tolerate. And it turned out that I was at DEC, Digital Equipment, at the time, and then people there were building a system. It was a distributed, a fault-tolerant memory system that would be a shared memory for basically everyone in the lab. There was a lab that was way ahead of the rest of the world in those days. We actually had a system of distributed computers that basically it was one big shared memory, and that worked at memory speeds. But they had an algorithm that, well, they wrote this program that they claimed would have this certain fault tolerance property. And I looked at it and I said, well, I don't think that problem can be solved. What they claim it was doing, I don't think is possible. So I set out trying to prove that it was impossible, but I failed at that and instead found an algorithm that could do it, and that was Paxos. So that's how Paxos started. But again, it was solving the same problem that it solved with the time clocks paper, and in that later paper for handling Byzantine faults, except it was more efficient than the one for handling Byzantine faults. And it was better in two ways, because the one to handle Byzantine faults required using synchronized clocks and with known message passing delays. But that was not a good model for the internet, where we could assume that computers failed by just stopping, but we could not assume that message delivery was, could be guaranteed to happen in a bounded length of time. So that's what Paxos algorithm did. It solved the same problem, but under those different conditions.
Yeah, let me, for this young generation, maybe I'm not familiar with term like SRI. So SRI stands for Stanford Research Institute, and it's a private research institute very close to Stanford University, which has always been on the leading edge of, most exciting computer science program activities, and that's one of the many exciting places where Leslie worked in the past. Then he mentioned that the Digital Keeper Corporation, that is was a very successful, especially in distributed computing company. I mean, they arrived to be in the top 2 or 3 computer company at that time in the 70s, 80s, and it was very, very full of very smart engineer founded by Ken Olsen, fantastic guy, fantastic engineer. But it was a company developing system for engineers, not for the large public. So they were slow in adopting Unix, slow in understanding the importance of internet, and eventually, they they were acquired, I think, by Compaq, and then Compaq was acquired by the Department of Enterprise. So one of the many casualties of the history of computing, but another very, very exciting place to work, and another place where Leslie has worked in the past before joining Microsoft. Okay, next question.
Talking about the program, I first knew the computers in my elementary schools. At the time, I still used the floppy diskettes for the storage. And during my undergraduate study, I learned programming language. And probably the first programming language is for bubble charts. And for in your experiences, what kind of first computer program do you make? Could you share with us?
Well, I mean, before I became a computer scientist, while I was studying to be a mathematician, I learned to program and worked in summers and part-time jobs programming. But when I learned to program, I programmed in machine language. That is directly in the code that the computer understands. And computers were a lot simpler in those days. And so it gave me oh, somebody wants me to start the video. Should I ignore that or?
Yes, yes. We can start video.
Yes. Or
You want to start the video, Leslie?
No, something popped on my screen saying that the co-host wants me to use video, but I don't know if that was some human being that did that or just Zoom decided that I should turn on my video. Why don't we just work it without I'm not terribly exciting to look at, so well, let's ignore that. Okay, so programming. The computer science suffers from what or many computer scientists and certainly programmers suffer from what I call the Worfian syndrome, which is the confusion of language with reality. And people spent a lot of time, worrying about languages when they should be worrying about what the language is trying to express. So, what I learned when I started writing algorithms is that if you're not writing a program, you shouldn't use a programming language. And an algorithm is not a program. An algorithm is something higher level. So as a computer scientist, by the time I started working on algorithms, I stopped writing code, except I would occasionally write programs for my own use. And there it was, what languages I used wasn't terribly important to me. As somebody once said, and this was in 1972, I always program in the same language, regardless of what compiler I'm using. So I have a way of writing programs that I learned, and I do it, I'll write programs the same way, regardless of what language I happen to be using. And I generally just use the, a subset of the language that I can understand. And languages are getting to be so complicated that nobody can understand them. So, one learns a subset of the language that they can understand and then sticks to that. And that's what I do with programming. So, stop worrying so much about coding languages. And when it came to writing algorithms, what I finally realized, and high-level designs of programs, that is the specification, the description of what the program is supposed to do and how it should do it, best way to write that is in mathematics. And I developed a way of doing that in mathematics, and that's the way I write algorithms basically in mathematics.
Okay, Leslie. Since we had to reschedule, unfortunately, we only have 1 hour slot, and I would like to leave some time for the student here. Of course, super eager. I need to get some advice from you. Well, I know you don't like to give people advice because everyone is unique. Everyone has his or her own experience and aspiration. But I'm sure any of us does not have that many opportunities to have direct access to reference. I mean, how many there are alive in the world? Less than 50. So again, we're very honored, but we want to profit really, to give, to inspire also, young researcher. The generation is going to replace us. So I would like to open it. So I think that was the first question, wasn't it? Yeah. So now let's go more in a free mode, if you allow us. So I really would like to open the floor. It's your opportunity. Of course, hopefully there will be at the school another opportunity to speak to Leslie and other luminaries. But profit is last 20 minutes. So who wants to start asking Leslie the question? Yeah, there is a question. Can you bring your microphone? I don't know if they set that again. So say who you are. Say who you are.
Oh yeah. Thank you, Leslie, for the nice talk and the advice for us. My name is Arman from Research Center for Quantum Physics. I do a lot with LaTeX since I was undergraduate student. So I think up to now, LaTeX is already well established. So my question is, what is your next dream about LaTeX?
I stopped dreaming about that 30 years ago or so. In 1995, or approximately, I did one of the smartest things I've ever done, which is to give LaTeX over to some other people, Frank Mittelbach and his colleagues, and they are the ones who are now responsible for it, and I don't think about it anymore.
Okay, thank you, Leslie. Who wants to ask the next question? Don't be shy. You don't have that many. Okay, yeah.
There's a hand up behind you.
Hi, Leslie. I'm Nazif from Malaysia. Okay, I don't know if this question is good or not, but I just want to know because I heard about one new operating system is being developed, which is called based on database, which is database OS, and it's coming from MIT, I think. So, how do you see this OS progressing in the future? Will it be our next OS? That's what they claim from that.
I've never heard of it. I know very little about what's going on in operating systems, so I can't say anything about what's going to happen in the world of operating systems.
Okay, got it. Well, I also don't follow operating system any longer since I switched to Linux. Other questions? What one? Oh, yeah, I don't know. Okay, I'll go. Okay.
Thank you for the opportunity. Hello, Leslie. My name is Eva, and actually, I have the same background with you, like a mathematician who produced a lot of theorems and proofs. Actually, you are one of my idols because because I love the way how you think about algorithm, and I have saw one of your interview in YouTube, and you say that you think computer as a mathematician. Can you tell me more about that? And the second question is, as we know, you developed DLA Plus. I saw that it is very interesting. And could you please share about DLA Plus? And as a mathematician with not a lot of background in computer science and programming language, can I use DLA Plus to learn another programming language or create some useful thing about computer? Thank you.
Okay, I missed a word or two. You had two parts to your question, and I missed a word or two about the first part. If you could repeat that quickly.
How do you think about the mindset that said a computer as a mathematician?
Well, the thing about computing is that you have to be rigorous. You get a bit wrong, program can crash, and that takes rigorous thinking. And the best way of doing rigorous thinking is mathematics. What I found is that what TLA Plus is, it's it's a language which okay, let me start. I should start at the beginning. There are two kinds of properties. There are two classes of properties. The properties I'm interested in are things that are true or false about a single execution. So what they are mathematically are predicates on executions, where an execution is just a sequence of states. And there are two classes of properties. As a matter of fact, you can prove that any property is the conjunction of these two. One is a safety property. And intuitively, what a safety property does is it says what the program is allowed to do. And the thing about it is that if behavior does not satisfy a safety property, then you could, for example, that program produces the right answer, can only produce the right answer. Well, if it produces the wrong answer, that's a safety property, because if it produces the wrong answer, you can point to it and say, here's where it produced the wrong answer. Termination is a liveness property, and you need to see the entire infinite behavior to know whether or not this liveness property is violated. Because you can't say at any point the program is, is got to see the entire infinite behavior. Now, what I learned is the way to describe safety properties is by what I used to call a state machine. What you do is a behavior is a sequence of states. What your state machine consists is specified by an initial predicate, something that says what the first state must satisfy, and then a predicate that says what every step must satisfy. That is, and if you look at programming languages, that's generally what they specify in terms of an initial state and a next state relation. And that was the nice thing about learning programming the way I did on the computer, because computers were simple and it was easy to see then and the program and what each step of the program allows. And there are lots of ways, and the thing, as I said, that people are, this Orphean syndrome, that people are hung up on languages. If you look at any method for specifying systems that works, they specify safety, they do it by an initial predicate and a next state relation, but they have all sorts of different languages and ways of expressing that. But mathematically, the essence, that's what it is. Now, liveness properties, it turns out that the best way of describing them is with temporal logic. The temporal logic is a very obscure branch of mathematics that Amir Pueli in 1977 introduced it into computer science, and he won a Turing Award for that introduction. It was a big advance. And what TLA does is a way of, it's a temporal logic. Amir Pueli had very simple temporal logic, just had one temporal operator, which said always. So you could say that something is always true. And you could say that something is eventually true because it's not the case that it's always false. So you can specify, so basically that something is always true is a safety property, that something is eventually true is the liveness property. And so you could, it turned out that his simple logic was not enough to specify you couldn't specify a state machine with it. And so people invented lots of temporal logics to try to express them as state machines, but they all failed. And I had the idea of, and what they did is by having more temporal operators, instead of box just always, they will say this until this, you know, every alternate Tuesday or something. It got really complicated and it just didn't work. What I realized is that there's a very simple way, change addition to Noelli's original temporal logic. The basic formulas of his temporal logic were state predicates, statements about a state. The generalization I made is to have them as predicates on steps, on pairs of states. So to say that, you know, to specify, you know, what the possible steps are, you have a predicate on pairs of states, and then you say, box that predicate. That predicate is always true. And so with that, we can specify both safety and liveness in temporal logic, and that's what TLA does. Now, TLA plus is what I also discovered. Most of the complexity of describing what a concurrent system does is in the safety part. And the safety part is basically the specifying that next state relation. And that next state relation is basically an ordinary mathematical formula. So what you do is it's to make it a predicate on pairs of states. You write the first state is in a variable x, with the value of x in the first state, and x prime is the value in the second state. So you have variables and unprimed variables, but it's just an ordinary mathematical formula with primed and unprimed variables. And most of the TLA plus, and so most of the complexity is in that mathematics, in describing the next state relation. And that's exactly where you want complexity, because mathematics is great at dealing with complexity. And so describing, we're doing math. And what makes TLA plus work so well is that it gets the people who use it to think about the computation in terms of math. And most engineers and many computer scientists are afraid of math. And so it's something of a hard sell, but they get sucked into it because TLA Plus has a model checker. And a model checker is a tool for, you know, finding errors in your high-level description of what you're doing, which is a very useful thing to do. And so, you know, they discovered that, but what they learn, if they're smart and if they keep doing it, that the real benefit is that it changes the way they think by allowing them to apply mathematics to their designs. So that's what TLA Plus is all about.
Thank you, Leslie. I think we're reaching the end of our slot. So I don't know if I think, as I said before, I believe all our students here, they are looking for advice, guidance, how to evolve their future career. One of the concerns that I have, and it's kind of related to what you were saying. I mean, basically you are saying, mathematics is fundamental if you want to do correct programming and good computer science. Unfortunately, it just happened that there is a tremendous hype behind, machine learning, AI, generative AI, or whatever you want to call it, and also the big companies who are already making, they're making not already big money, but they expect to make big money. Let's not mention it, but the big IT company are a little bit distorting the situation because they offer great salary for the people coming out from university, push them towards those kind of things, which I have the impression is a little bit, everything goes. Okay, you arch together the system, a large neural network, you put there through the system, you let it go, and well, it works most of the time, but not all the time. And somehow we're losing a little bit the idea that behind all that there need to be rigorous thinking, rigorous analysis, and fundamental mathematics. So that is my worry. I don't know, Leslie, if you have anything to comment to that.
Well, I mean, AI is built on mathematics. Basically, what you want to be paid to do is to think. And math develops your thinking. So that math is great it was great for that reason. But the other advice I give to people is to write. People ask me what I do. I sometimes like to say I'm a writer, because what do? I write papers. And there's a cartoon that I love that's a caption is saying, writing is nature's way of showing you how sloppy your thinking is. And you should learn to write. And most people, and programmers especially, hate to write. Writing is something that you need to practice and need to get good at. Because if you can't write well, you're not going to be able to think well. And if you don't think well, you're not going to be able to write well. It's it's either a vicious circle or what do they call it, a virtuous circle. If you learn to write well, you write better, you learn to think better, and you learn to write better. And the way you do that is make sure that everything you write is as good as you can make it. And that means every email you send. You don't just dash something off, but you write it and then you read it. And you say, could that have been stated better? Could that have been made more concise? Is it ambiguous? And do that with everything you write. And when you have ideas, when you're thinking about, what a program, you're writing a program, write down what it should do. You don't have to use any formal language, whatever, but just write down as precisely as you can. Because that's, is what will improve your thinking. And also, writing is a skill that's very important because, if you become a computer scientist, you're going to write papers and you're going to be judged by the papers you write, not by what you're thinking. So, writing is really important. And thinking is important and math is important. So, don't worry so much about languages, especially coding languages. Yeah. By the way, I've stopped calling them programming languages. I'm calling them coding languages because they're part of programming. And so, TLA Plus is a language for programming. It's not a language for coding. Okay, that's what I have to say.
All great advice, and if I can summarize, use mathematics, study mathematics, that will train you to do good thinking, and then when you get an idea, translate your thinking in writing a paper, you publish a paper. If the paper is rejected, well, that will be a good experience, and it will push you to do better next time, to revise your paper. And I would like to add something. Teaching is also an expansion of that. So you write a paper, but the paper can be maybe understandable, maybe not, but if then you try to give a lecture, you don't need necessarily to become a teacher or a faculty. Just go to conferences, present the paper, and if you don't really get the message through, well, go back and think again. There must be something wrong in what you have thought, or the way in which you express it, the way in which you have written, the way in which you present it. So think mathematically, write what you have thought, publish it, or present it in a conference, and then try to explain to people what you have written and see if they get it. And then I think in essence is what I believe Leslie has told us. And with that I think great advice. I really like to thank you, Leslie, for your time.
Okay, can I have one word?
Sure, of course.
If you look on my publications page, there's a note that I wrote sometime in the 70s. It's calling something like How to Present a Paper, or something like that. About 2 pages or something, Read that. It's a little obsolete because it talks about making slide, transparencies, which you're probably too young to know what they are, but that's some words of good advice in there.
Yeah, that's great. By the way, at the time of transparencies, you have to spend a lot of time in deciding what to put in transparency, because if you get it wrong, you have to start again. Now with PowerPoint or any other system like that, well, you import slides from here and there, you modify quickly, so it becomes a little bit sloppy. As in slides has also been a great experience, because writing the slides, with pencil, it was, a good 10 minutes per slide. So you didn't want to start again. So I think, transparencies. I think manual transparency was a very good experience. I was terrible with that, terrible drawing capability. Anyway, Leslie, unless you have any additional words or advice to say.
Well, I think I've said what I have to say.
Okay, great. So thank you again. Hope to be able to see you soon in a screen class. Okay.
Thank you.
Yeah, good evening. Asking for the sake of what do we have now? A break or what? Break. 10 minutes break. 10 minutes break, then we go to
Okay, 10 minutes break. And we go with the educational panel. I think the Saputra we begin at 10:10.
It could be master's program, PhD program, especially postdoc opportunities. So this is something that you want to pay attention to. Perhaps this is your a lot of opportunities will open up for you for your academic career, for your research career. Before I start introducing the panel, let me, as in my capacity as the co-chair of ASEAN HPC Task Force, there is a task force under ASEAN that was established in 2018, so about 5 years ago. It was established at MEC for the first time in Singapore 5 years ago. And when we met in 2018 in Singapore, we did not envision that 2-3 years after that, we already were able to organize a school. And this is thanks to E-Ready, who happened to be at the, kind of the same time and found us and then supporting us from the first HPC school, virtual one, 2021, the second one in 2022 in Bangkok, ASEAN, and this is the third time. So on behalf of the ASEAN HPC Task Force, I would like to thank again E-Ready, Dr. Ado there, and his team has been very supportive of this school. Thank you, Ado. And we also would like to thank all the KOL. The ASEAN HPC Task Force consists of 20 members. Every member state, every country of ASEAN member is represented by 2 KOL or key opinion leaders. From Indonesia, it's me and Parifki. And then from Thailand, it's Kun Piawut and Kun Supa. And then from Malaysia, there is Suhaimi, maybe he's still having coffee. And basically we have 20 people represent this ASEAN HPC Task Force. And yesterday evening, the KOLs that are here have met and decided and made a commitment to continue the school forward. That means there will be another series of ASEAN HPC School 2024. The details will be announced soon, maybe during the Q1 of 2024, where and exactly and when. We are diligently working on that to get it out. So usually we announce it by the end of March or the end of February. Super Jump Indonesia, that will be announcement. Okay. So also I would like to thank the lecturers, the instructors. I would like to stress that they are flying all the way. This is out of love, because professionally they are not paid. They are just compensated for the travel expenses, because we can't afford paying them. Like parent is like, I don't know how you know your hourly rate, but they are doing it out of love to you, love to all. And this is exactly what we are trying to do here in this discussion. And Kun Piawut will tell later that the very first meeting in Singapore, we immediately recognized that talent development is a critical issue. We identified that, and a year later, E-Ready came along and then, hey, we are E-Ready, can we get to know each other and shake hands and then so on and so forth. So this is thanks to E-Ready. But also then we had Japan EU ASEAN Symposium in Singapore 2 years ago, and then Japan also came along and helped support us. LinkedIn, led by Satoshi Sensei, sent 8 people on LinkedIn's expenses. So we are not paying them. LinkedIn sent a budget sending 8 people like Chikusa-san, Monaka-san, Kengo-san, they have left, but 8 people sent by LinkedIn. So that is something that we should recognize and appreciate. Without that, this tool will not happen. So this morning we have 5 panelists, 4 here offline and 1 from Singapore. So I will start introducing one. We'll start with Kun Piawut, Dr. Piawut, and then followed by Wahid Sam from Weekend, and then Catherine from University of Luxembourg, and then Susan from Euraccess, and then ended by Arthur, Dr. Arthur. All right, so let me first, the idea here is to give you information, lots of information. What is available for you to advance further in the area of HPC. So Dr. Piawut, he is now the Deputy Executive Director of NACTEC. It's a research organization under NSDG. Is that right? He is the former co-chair of ASEAN HPC Task Force, but because he's promoted and he's very busy within NSDG body, so he asked me, can you replace me as the co-chair? So now I'm the co-chair along with Mr. KTK from Singapore. So the co-chair, there are 2 co-chairs. So Kun Piawut, time is yours.
Okay. Good morning again. So now I'm here in person. I was on this call about opportunity to continue on our dedications. From the task force, I think it's more like the opening part to host the rest of our speakers. Okay. Well, the history of ASEAN HPC Task Force, I remember that in early 2018, I got a call from, I got a call about 9 a.m. when I was about 40 kilometers away from Bangkok to get to lunch in Bangkok. So ASEAN was having some kind of meetings, and then they asked for the idea that ASEAN COSTI has initiation about, is it possible to have a shared HPC infrastructure and facilities among ASEAN as infrastructure to help supporting SDI level in ASEAN now, because this has been seen as it was pointed as important infrastructure. Anyway, and I was called to, so that it seemed to be like I cannot deny anything that says, can Singapore and Thailand push for that motion, in COSTI meetings a couple months later, and for this initiation. And then COSTI committee decided to commission a group called ASEAN HPC Task Force. At the beginning, the focus was simply to study the feasibility of bringing up or having the shared infrastructures that can be shared in member states on HPCs. Anyway, so a few months come along, and then the task force is set up. As Putro was mentioned, that all 10 ASEAN member states has to join, and there are maximum 2 key opinion leaders who represent HPC in each nations to join. Okay. The first round meeting, as Putro mentioned, was held in Singapore, if I recall correctly, maybe in September. Yes, so the first task was to explore what was given, because it was commissioned to do a certain job. And exploring of a capacity existing, where how small, how large, how medium size of HPC was located among ASEAN member states, and also the network connectivities. Okay, that job sort of done halfway through the meetings, and then there are discussions among the KOLs and say, what can ASEAN benefit? Just have computer cities, even though sharing over the network. When the real values of having them to create an impact to economies or social welfare of our nation in the communities, the computer cannot walk to do anything itself. It has to be orders. So there are two more elements which has become even more far exceeding. The first original message is the human capacities, talent abilities. That's one issue. And the other one is a meaningful application that would benefit us in the regions. So from then on, three elements has been formed in, sort in the vision of task force. First, shared infrastructures, HPCs, talent mobility, talent creations, human capacity building, and looking for the, worth investing application for ASEAN. So from day one, I would say that people are in our mind from the start, and that somewhat led to what we are here after 5 years with the ASEAN HPC School. The task force is working in a different way, in a strange way. All these 20 key opinion leaders are appointed volunteers. So the term might be conflict. It's volunteer that was appointed. So you don't get paid, you don't get any particular support office or anything like that. So it's just coordination of task force itself so far with the support of ASEAN Sec in terms of administrations, things like that. You have been volunteered. So, given that, including if you trace the fact of our ASEAN status, so we are pretty much saying we were not fully equipped, by any means to drive this one. So, but we do whatever we can in every way that the task force can do. Try to follow the mission, the three angle the mission that I just mentioned. So you see, from then on, there's a part of, say, shared infrastructures when the design of having ASEAN HPC system certainly is facing difficulty in terms of raising funds and hosting them and providing service on them. We have RTCS and Fugaku to thank for in the beginning that we are using Japanese HPC system for our sharing. Not only for the school that you see, where there's a portal that works with ASEAN Singapore as the sort of portal where we can submit the research project that we will run on the Fugaku. And the Fugaku itself opened itself to the world that you can access. You can submit a project also to run on the system if you got approval. So this doesn't happen before when we have sort of ASEAN HPC task force as much as it volunteers as it is. It has started acting as a focal point of contact for the regions. Come along to EU with great support from E-Radies. They are able to join. Actually, we have a second meetings of the task force in Singapore as well. We have large commissions from Europe come to talk with us, and so what would be the first thing to do? So at that point, I remember Fabrizio was online and offered seats to the ASEAN school in Barcelona. That was 2019. It's a long time ago. Can't believe it's come to 5 years now. Yeah, and that's one step that you see that there's a school like this. They were holding that, maybe even the largest context. And the idea is starting, instead of bringing 60 people over there, would it be able to bring the school to ASEAN? Yeah, that was one of the initiation that Fabrizio and the late Professor Puchon Yopan from Thailand. He passed away a couple of years ago anyway. Yeah, okay. Then he really come to support. If you notice, the first two schools was called EU ASEAN HPC school. We really play a very important role to bring this up. But even though it's called EU and ASEAN, almost a third of the proportion of the school come from RCCs, from regions. And they have continued to do so. The first two meetings, the first one was virtual due to COVID. The second one was last year in Thailand. And now here in Bogor. And they will receive this international support from that. So you see, even though we don't have any resource ourselves, we use this to networking, collaboration, and open up the opportunity for us. I think
Recording in progress.
Thank you, Dr. Piawud. Next from RIKEN, Wahib Sang, Dr. Wahib, he will be presenting what opportunities are there in RIKEN. Kobe is a beautiful place, you should visit. Nice place with very good Kobe beef. Over to you.
You can kindly show the slides. Maybe go to the first slide. Yeah, thank you. Okay, so hello, my name is Wahid. I'm from RIKEN. Those slides were intended to be represented by Professor Nakajima, who is the Deputy Director of RIKEN. Unfortunately, he left yesterday due to business today in Tokyo, and I'm presenting on his behalf. My name is Wahid. I'm a team lead at PI at RIKEN. I will try to get directly to the point because this is speaking about education or collaborative opportunities for people in ASEAN. Before I jump to that, I want to stress one point. RIKEN is an organization that recognizes talent. Yes, supercomputers are nice, the system before, the system after, resources are nice to have, but by far and most, all progress and all work and all contributions come from humans, not from machines, right? So resources is not just part of it. And based on that, RIKEN has for a long time, and RCCs in specific, put at the forefront of it, finding pathways and channels to recognize talent and prepare talent domestically and internationally to contribute heavily. To the extent that we even have a deputy director, Professor Nakajima, who's almost full time working on the educational aspect and human resources aspect of how to offer ways to have this knowledge in RCCS being transferred to the next generation and bring people along. I can probably go to directly the slide that you care about. Next slide. So those are because they're probably all the way. Yes. So no. Yes. No. One more back. One more. Yes. So those slides are intended to speak about the collective. Again, RIKEN, just to clarify, is a research organization. It is not a university, so we do not award degrees. That being said, it is a research organization where most of the staff working have deep ties with universities, and most, if not all, research staff have double appointments in universities. So while we don't give degrees per se, we work very closely with universities all around Japan, like University of Kobe, University of Tokyo, Tokyo Institute of Technology, University of Kyoto, and so on. Based on that, we always try to have our programs that reach deep to universities inside and outside Japan. By the way, I will share the slides on Slack, so you don't need to bother with different countries. Okay, since those slides are very generic, I'll just focus to what you would care about. So you probably should be looking at BC with X. BC is basically this axis, is basically the programs we have that target undergraduate and graduate students, right? And C, maybe D also, which is people who just finished PhD, let's say postdoc or so on, right? And you should be looking at the other direction at X axis international, because YNZ just covers more like domestic efforts, which might not be of interest to you. Can we go? I will go directly to the slide you care about. I guess you can skip the next slide. Yes, this table. Okay, so basically this table basically shows you exactly where you should be looking at. So you should be probably be looking at B, C, and D, especially B. C is basically, if you're a graduate student, graduate means master and PhD, right? And you should be looking at X, which is international. So any line you see that has C and X with like circles, or B or C or D with X and circles, this is what you care about. And basically speaking, you can see there, for example, in red, you have the lines in red basically which you're looking at. So we have a wide range of programs from international computational science internship. Those are internships awarded to bright students. Again, we recognize talent. This is very important. From international, from outside Japan basically. And those would come and spend some time, typically within 3 months. Those are awarded internships directly from RIKEN RCSS Center, and I will explain in the next few slides. That being said, also teams can directly, if they have students you collaborate with or a lab you collaborate with, award internships for some time, 3 months, 4 months, maybe more sometimes, maybe less, to graduate students, master, PhD, most PhD, and even early stage postdocs. There is also the International Summer School, which looks like this setting exactly, which is hosted in Japan, and is intended to be a short program, maybe a week, sometimes it's more than a week actually, where it looks like, but maybe the format is a little different. Here it's more like giving high-level fundamentals from lectures and then breaks into tracks. But this one is like a hackathon, where people already before coming have specific applications they want and want to make them faster. So they already come with a very clear target ahead of time. And this is for probably already experienced users who know how to do HPC and programs for computers. This is also the summer school. And of course, the one last one we already are sitting in it, which is Agile HPC summer school. Can you go to the next slide? Next slide. So the internship program, here is covered, like I said, the international internship programs, it's usually, deadlines are February. So if you consider applying, actually deadline is like 2 months from now. You should probably apply. We accept, I think there's a table at the end that shows the number here, usually up to 60 or 70 people. I would say it's pretty competitive, but not cutthroat competitive. So maybe 1 out of 2 or so. Not 1 out of 10 or something like that. Okay, it's intended for PhD students, but if there's a private master student, maybe they can accept. And the intention is not just to have someone to come as an intern and stay, a few months, collaborate and leave. It's for all the ongoing work that can be mostly done. As you've seen, all access for back over here. Sometimes you don't really have to be physically in the same place. And in some cases, rehire a lot of these old terms. I'll go to the next slide and that and explain. Can you go to the next slide, please? So this, for example, shows you just a high-level overview of the number of interns. As you see, there was a big drop. The first in row is what you should be looking at international. Those programs started very recently, and then of course COVID came and made it hard. It was remote. Now we're ramping up, or we went to 27 last year. I think next year we're aiming for 60 or 70. The budget does exist for that, and a lot of people quite like it. And I will just note to the last one again, we recognize talent just as it's a way to give interns the means to come and using resources and also experience from people really to help them advance their research and publishing gradually. We also can clearly benefit from that, recognize talent. So just to give you a hint, for example, after finishing PhDs, a lot of the interns were hired. I personally in my team hired like 2 out of maybe 5 interns and so on. We were happy, I was happy. We extended the collaboration with most of the business that we hired. And one of them even went out and became a PI all the way. But that's not the intention, right? That just happens organically. It's not like, hey, let's go and see who's willing to stay. It just happens. Some interns are happy. We are happy. After they go back, we continue collaboration, and then it just naturally happens. Next slide, please. There's also the summer school, which is different from internship. Again, summer internship is maybe clearly you apply and you express your desire, which students you think are close to your work, and you submit a research plan. and then the PIs, they can look at it and they try to match if they accept the students because there's clear alignment in interest. Then it's accepted, then it's focused for 3 months or less to get some research done on the hope that it kickstarts ongoing collaboration. Summer school, again, is a little different. This is like focused, intense 1 to 2 weeks of courses, just like this school. Sometimes it's like this school, but it has a curriculum that covers from high level to hands-on to many tracks. Sometimes it looks more like a hackathon. People come with a clear problem before coming. They have a code they are working on, and they want in that week to take a big leap to improve their work. And we have both types of program, so you might also want to check on those. And the dates and deadlines and everything are linked on the last slide. So don't worry. I'll show the slides. Next slide, please. And those are basically programs of summer school. I don't think this slide is very relevant, please. And just to explain, like, by the way, those programs don't necessarily just cover resources at Beacon and Fugaku, because we have very deep collaboration with Germany and Japan. So a lot of the interns or students, when they come, they also use other systems in Japan. So for instance, a lot of, like I see in the last line, Fugaku was used in 2022, but there's a e-talk system, a big system called Forest that was used in 2021, 23. We have a wide range of resources and supercomputers. Fugaku is a flagship system, but we have access to, say, maybe a dozen reasonably sized systems with different technologies, CPUs, and so on. So that's also a benefit that during the internship and summer school you can get access to that. Next slide, I think I have one more slide on my own. Okay. This is just to show you some stats on the international HPC summer schools, and those are students who already know what they want. This is not an internship, they come to work on a code. The unfortunate reality is we don't see a lot of from ASEAN, right? You see a lot of maybe Japanese university, domestic and international. But for example, we had a high spike 2021, 2021 from Singapore went to 0, but that's because we had another program in Singapore other than that directly between us. That's why it doesn't come clear here. I think for ASEAN, again, but remember those were COVID years, like 2021, maybe 22 even, so that doesn't really reflect the reality. But still, a lot of work can be done, and I'm certain we can do much better now. I guess we can skip that to give time for our panelists. Finally, I will share the links from here, but I will also share those slides. Let me just reiterate what I said. I'm glad I was here to see a lot of bright young people. It's a great time to be doing science and engineering with a lot of change in technology at the HPC and also coming AI and such. We recognize talent, work harder. Sometimes there's lack of resources, don't let that get in the way. I myself, like you, had a big part of my education in a developing country, so I don't get be frustrated not having access to resources as supercomputers and such. Just keep pushing, find opportunities, and keep building on that, and good things will happen. That I think I finished, and I'll expand.
Thank you. Ohayim-san, domo arigatou gozaimasu. Very a lot of opportunities with Fugaku with weekend. By the way, how many of you are aware that there is a call for application, call for proposals to Fugaku, which will, the deadline is the end of the month, December 31st. This is for all ASEAN countries, ASEAN members. In 2 weeks, there is a, if you are not aware of that, please contact me. I'll share you with the information about the application. We have sent the information to your KOL of the respective countries, but if somehow you haven't heard about this, there is this opportunity for you to submit proposals by December 31st, and then evaluation in January, and then from February to July, we have access to Fugaku. Okay, that's one. And second, remember during the networking dinner on Monday night, there is a Director General for Higher Education of Indonesia. He is responsible for 10 million university students, 30,000 faculties, and 3,000 universities, right? So he actually made a deal with Satoshi Sensei, to send, and this is actually for Indonesian participants here. We are going to send out call for application in January for program in June, July, and August, open for Indonesian. So the deadline of that will be January 31st, announced in 2 weeks later, and then after that will be proposed for June, July, August internship. So this, you should take a note of that. If you haven't heard, if you haven't received any call for applications, contact me the first week of January. Okay, next, I will introduce Ms. Dr. Catherine Saleme Luis from University of Luxembourg. She's a postdoc at the University of Luxembourg. So you use this pronunciation? Not yet. All right. So over to you.
Hello, thank you everyone. First, let me thank the organizers of this beautiful event for inviting University of Luxembourg. It was meant for Pascal Bourri to come here, who is the coordinator of the EU Master for HPC, but he couldn't make it, so I'm here presenting the project. I'm actually the project manager of this program. I will explain a little bit more later. But first, thank you, the organizers, and thank you everyone for being here today. Yes, I work at the University of Luxembourg in the computer science department. I'm myself a mathematician with background in computational engineering, so I got to use HPC a lot during my research time. Now I'm more in this managing kind of job, so that's what I'm here. Can we go to the next slide, please? So, the EU Master for HPC is thinking. So the EU Master for HPC project is an educational project funded by the Euro HPC Joint Undertaking, the European Commission. It is composed of a consortium of more than 60 partners. We have 8 awarding universities from Spain, Luxembourg, Italy, Switzerland, Germany, Sweden, and Bulgaria, and Italy. We have participant universities from all across Europe and Euro HPC participant countries. We also have other contributing partners from research centers, SMEs, and industry. And as you can see there, the list is quite big. The main goal of this consortium is to build the first pan-European master program in high-performance computing. We started this project in 2022, and we are building the curriculum, the entire program. The idea is to harmonize the HPC trainings across Europe, trying to take advantage of the good quality programs that the universities in Europe have and trying to put it together. At the same time, so not yet. At the same time, we are testing this project by running the pilot program. So that's why we choose the 8 awarding universities. So we are building the body of knowledge, we are building the curriculum, but we are testing it at the same time. So we are now in the second cohort of students, and we are just opening the third cohort recruitment of students as well. So can we go to the next slide, please? And with this slide, I just wanted to explain to you the academic journey that we are developing. So This is a 2-year master program that includes mobility among the awarding universities, that also offers as mandatory several academic activities like workshops, challenges where the students compete, internships, and summer schools, which is a very good complete program. In the first year, the students will take HPC fundamental classes, and they have to choose the first awarding university they want to start there. And then, after finishing the first year, we have the summer school, we have the challenges. At that time, the students will have already completed 1 or 2 workshops where they get interactions with industry. And then in the second year, they have to move to the second awarding university to get the specialization courses. So for the specialization part, we choose, please, 5 different topics: application domain expert, numerical and data specialist for science domain, performance analyst and advisor, system development and support, and system architect. So we have a core group working on defining how these topics are going to be reached. And we are leveraging from the expertise that the awarding universities have, because each one of them have a specific specialization kind of background. And then in the 4th semester, the students have to go to an internship. It could be in a research center, it could be to a company. And for this, we also have among the partners a task force to collect these internships, to evaluate them, and then offer to the students. So we are accompanying the students from the beginning to end in all this academic journey. Another thing that I didn't mention here, but it's also included, is a part to where the students get training in transversal skills, which is very important. As we were mentioning, writing is very important skills that you have to practice. So we have included this in this program. So students also will have training in not only writing, but also how to do research, licensing, and all these transversal skills: how to present, how to write CVs, how to write papers, and how to work in teams, which is a very crucial skill that we all need to have. So this is a general overview of the program. Can we go to the next slide? So if you want more specific information, you go to the website, and there you will find more information about this program. Thank you. Yes, I mean, initially people can apply. Yes, the thing is, we have some support, financial support, but because this is an European project, priority are the European students to get the scholarships for now. But the idea is we are testing this pilot program, so we start locally. We are trying to define, to build up, to create something new, and the funding we have for the scholarship and for European students. But you are also welcome to apply. If you have the minute, you can find another funding to go and participate in this program.
Thank you, Catherine. She will stick around, so if you have any further questions, you can approach her for further information. Next, we will invite Dr. Susan Renzo Fasu. She is the Regional Coordinator of EURAccess Worldwide ASEAN. She is based in Singapore. Susan, over to you. The screen is yours.
Thank you so much. I hope you can all hear me well, and the connection as well. Thank you so much. It's great to be with all of you this morning. And I'm just going to share my screen here, and I hope that you can all see my presentation. So thank you so much. As you've kindly introduced me, I work for the EURAXES Worldwide Project, which is a project of the European Commission, and really our mandate is to inform researchers here in Southeast Asia of the opportunities to collaborate with European partners, and of course also for you to develop your career in Europe. So I'm just going to present to you today a little bit about the opportunities in the context of the so-called Horizon Europe project. And as I'm sure many of you know, this is the European equivalent of a national funding program. It has an overall value of about 100 billion euros, and this particular installment runs until 2027. And in terms of content, it is aligned with the policy objectives of the European Union member countries and the European Commission, so tackling climate change, digitalization, catering for aging societies, etc. So this is not very dissimilar from the national funding programs that you will find in your own home countries. The difference very much is that the key element here is all about international collaboration. The project is open to research entities from anywhere in the world. Researchers from anywhere in the world are very much invited to participate. You can see here at the bottom, Horizon Europe is very much open to the world, and this of course is based on the understanding that to tackle global challenges, researchers need to work together. This is what the program looks like, and of course in line with what we're trying to do today, namely to introduce you to opportunities for your own career development. I want to introduce you to the so-called Pillar 1 of this big program. It's the Excellent Science Program, and there are two programs in there which I think are interesting to you as individual researchers for your own career development. You can see here at the bottom, this is where in this big program we find grants for individual applicants like yourselves. First of all, the Marie Sklodowska Career Actions, and then afterwards I'll talk a little bit about the European Research Council grants. Now, first of all, the MSCA, I think this is a very strategic thinking of the funding body. The idea is really that you need to continuously train the researchers so that the researchers can in fact find solutions to the global challenges that the world at large is facing. So this is a very important element of the framework program. You can see here it's all about researcher training, skills, and career development. And importantly, this type of funding is meant for researchers at all stages within their career. It starts at the PhD level all the way to highly accomplished senior researchers that can also benefit from this particular program. And you can see here it has worldwide geographic coverage, which means, again, anyone of any nationality can apply for these opportunities. There are two programs that I think are interesting for the audience, as far as I can see from my screen over here. First of all, the so-called doctoral networks. And secondly, I want to introduce you to the postdoctoral fellowships. Now, first of all, the doctoral networks, what this is really unique doctoral programs that are not implemented by a single institution, but by a consortium, a partnership of different organizations from across Europe and beyond. They might also partners from other parts of the world, and institutions that are from outside the academic sector that come together to form a doctoral network and really to train the next group of leading experts in a specific thematic area. And of course, HPC computing is one of the areas that is very much covered by this particular program. So you will find MSc doctoral networks in all scientific disciplines, including, of course, the natural sciences that you are all interested in. There are different types of networks. There's a standard doctoral network, which means you carry out your research at different institutions that are part of this particular training network. They're based in different countries, and then you come away with a PhD. You could also, for example, opt for a network that offers industrial doctorates, which means you will have a joint supervision by an academic supervisor, someone based in a university, and someone who is based in the private sector in a company. So it's a great opportunity to already make perhaps that transition from academia to industry. And then we have networks that offer joint doctorates, where you also besides the international, the intersectoral, and the interdisciplinary mobility, you will walk away with multiple doctoral degrees. So all of these are available to you. And where do you find these doctoral networks? They're offered all across the so-called European research area, which you're perhaps familiar with. On the left-hand side, the 27 EU member states. On the right-hand side, countries associated with the European research area. And I haven't put this in here, but as of 1st of January next year, the UK will be again part of Horizon Europe, which means you will also have the opportunity to participate in these networks where there are British universities and British partners that are part of the network. These doctoral networks are fully funded. Again, they are open to all nationalities. You get a very generous living allowance. You get a mobility allowance, which of course is important for a mobility program. And you also have a family allowance for those of you that already have dependents. And I think that's new. You get the family allowance regardless of whether or not your family actually comes with you to Europe to pursue your PhD. Now, where do you find these programs? You find them online. We have a specific database where all these open positions are being advertised, and importantly, there is no fixed deadline. These positions are advertised throughout the year, and it's important for you to continuously take a look at the particular website. And at this point, let me tell you, I will of course share my slides with the organizers, and all my slides are hyperlinked, so it's been very easy for you afterwards to look at the database. And I had a look this morning, just now, you can see here, I just looked at the keyword computing, and I found 76 opportunities at this point in time for you to pursue your PhD in your field in Europe. The second program is for those of you that already hold a PhD and you're perhaps considering a postdoc fellowships, and I'd like to quickly introduce you to the MSCA postdoc fellowships, a highly prestigious program, and you might be hearing this usually in the context of people that go on to win a Research Council grant or maybe a Nobel Prize. They usually all start out as MSCA postdoc fellows. So this is a program, you can see it's a mono-beneficiary, actually means a grant for you as an individual applicant, and we have a postdoc fellowship for researchers that are currently based outside of Europe, for example, somewhere in ASEAN, for you to spend some time in Europe. The funding period is between 1 and 2 years. Once again, it's open to all nationalities, and the principle that applies here is the so-called bottom-up principle, which means there are no predefined areas of research, but it's up to you as the applicant to come up with your own research topic and your own proposal. These fellowships are awarded once per year. There is one call per year. The next one for you would open on the 10th of April with a closing date in early September, but then there is the next one in 2025, and there'll be another one in 2026. Now, who is eligible for this? You should already have a PhD when you apply, when the call deadline comes around. You must have a PhD in hand, and you should not have more than 8 years of research experience. And let me just emphasize that again, there's always a little bit of confusion. It doesn't mean you need to have 8 years. You can also just have been awarded your PhD and half a year of experience. But when you have more than 8 years of research experience, you are no longer eligible. And as I mentioned, this is a mobility program, which means you have to move to Europe to carry out your research there. And you can do so together with a host institution that is anywhere in one of the EU member states or a so-called associated country. And just again to clarify, none of the ASEAN countries are associated countries, they're so-called third countries, so you will have to move to Europe to carry out that particular project. This is the funding. You can see is not have to worry about anything, but to do excellent research. And there are lots of opportunities to help you get started, because of course one of the key elements is for you to find a partner in your matchmaking platform. I just took a look this morning. As you can see, you can find potential supervisors here on the left-hand side. For one of these fellowships, currently there are 503 people that are available for just that. So again, there are lots and lots of support tools online, and we have a lot of links online to also help you get started with this particular application. Finally, as I said, I want to quickly introduce you also to the European Research Council grants. This is really funding.
Excuse me, Susan. Is it possible to share the rest of your presentation to us? We have to have a hard stop at 11:30, and we still have one speaker and perhaps Fabrizio. Unless the organizing committee is giving me an extension of time to 11:40. Can you finish it up in 2 minutes, Susan?
I can indeed. So the European Research Council grants, again, opportunities for individual researchers. These are the grant schemes. And this would be for those of you who really have a groundbreaking idea. You have trouble finding a funding body that is willing to take the risk. This is really your opportunity to get your groundbreaking ideas funded. You can see, again, different career stages where you get funding, highly prestigious, lots and lots and lots of opportunities for you to get support. And maybe here the sole evaluation criterion is excellence. Reasonably simple application. For you, perhaps looking at how old you all are, July 2024 is when the next starting grant call is opening, with a deadline in October, and I'd really like to encourage you to pursue this. I wanted to just show you as final slide, our slide, because Euraxis Worldwide is the institution in ASEAN that is here to support you. If this was all too fast and you'd like to find out more, just drop us an email here at the bottom. We're in ASEAN, and we're very happy to do other online presentations or meet you in person to guide you through the different opportunities. Thank you so much.
Thank you so much, Susan. It's a pack of information, so it will be helpful to have the presentation shared to all of us. We'll have the organizing committee to put it on accessible to everyone first. Now, let us, has to say, he is the talent development manager of BRIN, the agency that hosting the school. So before we let him start, let us give BRIN a round of applause. So Dr. Arthur, Dr. Rifki, Dr. Andrea, they are all part of BRIN.
Thank you, moderator. Thank you very much. My name is Arthur, currently Director of Talent Management. I will be giving a short slide. Can you go start to my slide? I have around 10 minutes, right? Yeah. First of all, thank you very much to the committee for having us today. This is the chances for us to have a strong potential collaborations. I'll be starting on how we can move forward. Like Susan mentions, those kind of doctoral in Europe, postdoctoral schemes available in Europe. I'll be focusing on what BRIN can offer here. Can you go to the next slide, please? On the slide, yeah, this is our program. I'm coming from the Deputyship of Human Resources regarding how we can have program related of capacity building, enhancement or development of educations. We have this what we call the degree by research program. I'll be focusing on that today. Second one on the BRIN LPDP scholarship program will be opening on February 2024, which is specific area. And the other program I'll focus on today is the research mobility program. Next slide, please. If we see here, there's a program. Next slide. Yeah, this is program where we have 2023 applicants awarded of our program. We have around, okay, I'll go on the slide. This is a slide where we talk about the capacity building. We have two ways of human capacity building. First is the LPDP scholarship program on the #1 program. The second one is on the degree by research program. Can I go to the next slide? I will talk on detail on the full scholarship LPDP program. It is quite similar with the regular LPDP program. The big difference is it has a specific research area. It has a designated host of research group. We know that LPDP has a short list 200 something university across the world, right? But it doesn't work that way for postgraduate studies. We want to identify professors, researchers strong in that research group across the world, whether he or she is not affiliated in that short list of LPDP universities. We gotta have agree upon that. So we have candidates. If that professor is coming from that not from that short list, is okay to be eligible as the professors. The third different is the re-entry program. The re-entry program here, the awardee of this program is allowed to have 2-time postdoctoral abroad. So usually after the LPDP, you're requested to come back home, right? But in this our program with LPDP, that's what we call the BRIN LPDP targeted program. This awarded scholarship program, the awardee is eligible to have 2-time postdoctoral. Can I go to the next slide? Yeah. The big difference is this 4 area. The regular LPD program, student can choose anywhere he wants to study, what field of studies. Eventually, at the end of the day, when you finish, more of them scattered around. They'll scatter around across the world. Sometimes you have a very quite thin network, and then they'll have some reluctance to come back to Indonesia. These 4 areas, meaning this is the 4 areas that BRIN currently having investment. The advanced biodiversity utilizations, not only we are not focusing what we call conservations, but on this genetic engineering. Here, I think colleagues can relate it with bioinformatics, right? This is the area we are identifying. We have 500 candidates during 5 years program, and I'm opening around 50 to 100 at February 2024. The second area is the deep sea maritime program, specific on the deep sea geosciences. BRIN next year will invest on the research vessels with having an ROV around 6,000 meter depth. Radiation and nuclear technology, we are focusing on accelerator technologies, accelerator. And for space and aeronautic, we are focusing on radar and satellite. If any areas related with computer sciences can be matched in these 4 areas, it's very open. Right? Currently, we are identifying professors, experts group across the world, related with this area. For bioinformatics, we have a collaboration with the ICTPs. Yeah, we already today we have maybe our opening discussion with Fabrizio or maybe Rosens later on. If there's a possibility to pinpoint a professor's expert group for this area. The big difference is the age limitation. You can see here, LPDP PhD program, they have around 35 years old. But our program, maximum 27 years old. So I'm going to campus directly across Indonesia together with my colleagues, scouting students at that age level. We want them by 35, they are mature enough, starting their scientific journey, because this is part of the Management Talenta Nasional, which 2045, we have the target to have Indonesia emas. This is the scheme is totally similar with the LPDP's regular program, but the difference is a specific area, the university is selected, and also the professor's area and the re-entry program. Can I go next slide, please? The second program I'd like to discuss is on the degree by research program. Since 2017, on the right side, we start with Indonesian citizens. Degree by research program giving opportunity students, civil servant, ASN or non-ASN, fresh graduate can apply as long as part of research collaborations hosted university across Indonesia and some university abroad. Since 2017, we have around 1,000 students. Starting 2024, requested by the Pak Kepala and the Ministry of Finance under the LDKPI, Indo-8 we call them, we are starting a program where international citizens can apply the degree by research in Indonesia, starting maybe ASEAN country, Indo-Pacific country, right? But in a specific selected university, because I have to make sure this university, this host university, can accept them, the international program and curriculum. On the right side, it is already ongoing, but on the left side here, 2024, we'll be starting it. The budget will be coming from the Ministry of Finance together with us. And these students will be in Indonesia. These international students will be in Indonesia doing their master for PhD. We are starting for PhD for the international program. For Indonesians, we're going for masters and PhD program. So I can go next slide. Philosophies of this program is what we call, we create the collaborations between candidates across Indonesia with the research group in BRIN, the lower part here. Once you create this platform of collaboration together with the researchers in BRIN as your co-supervisor, then identify the supervisor in Indonesia's university across Indonesia which we collaborate, then take that as your main supervisor and enroll in that university as a PhD student under our scholarship program. Well, I say it is not a scholarship under our program. We will cover the tuition fee under this program. So what we cover here is the tuition fee. We have the mobility scheme. You can be the research assistant there. So research incentive. If we can go to the next slide here, this is just a slide information with around 1,000 students are PhD candidates. Some on the right side is the university where we have collaborations. We have around 66 students, and the lower part of those universities are still undergoing discussions. Can I go to the next slide? The last slide I would like to offer, the researchers mobility. Suzanne mentioned that it's also open. You can go a postdoctoral in Europe. BRIN also offer a postdoctoral program. Currently, we have around 360 program awardee. For postdoctoral, we have at least a year and can be evaluated. But for visiting researchers, is 1 until 3 months. The output that we require for the postdoctoral is quite high, high qualification paper, while visiting researchers is the joint operations. The ones who's eligible, the doctoral is a fresh graduate up to 5 years after they graduate PhD with no affiliations, or if they have let's say, a lecturer, they have to be in a sabbatical leave. And for visiting researchers, they are professor with a high index at least 5. The terms and conditions, can I go to the next slide? It's an open requirement. It's based on expertise. Once your expertise is being needed by the host research group, they will come to us, they will make a letter to us, being that accept your proposal as their postdoctoral. For foreign nationality, they have to obtain immigrations. It is open for international and Indonesian citizens, but not for BRIN officials. So this is not for BRIN, outside BRIN, because we are inviting. Yeah? And they are willing to leave Indonesia during their tenure as a postdoctoral and visiting researchers. Can I go to the next slide? For the funding for postdoctoral, we can only give $1,100 a month as a living allowance. For visiting professors, $1,500 a month, and non-professor or doctoral degree holders around $1,250 a month. Those who reside from outside Indonesia will also cover their international airfare ticket. This is the thing that we can give for the compensation of your postdoctoral. Can I go to the next slide? The last slide. Currently, there's last slide. Okay. there's one last slide in mind here. There's 364 researchers. 35 of them are international foreigners, and from ASEAN there are 8 people, 8 positions, and we already have around 100 more publications for this program. Thank you very much.
Thank you, Partner. All right, we have a slide extension. So let's start with one question. Anyone who has any questions? I'll take one question for now. Any question? Yes, please.
Hello, my name is Abdullah from University of Malaysia. So basically, I got a question regarding the 2 years program at HPC. So may I know what's the requirement of pre-reducing before entering that program? Thank you very much.
For a specific list, please go to the website, but mainly we look for excellent candidates, which include you have to have a computer science background, but you can also be from mathematics, engineering, but you have to look at have some also background in computer science if you are not from the field. English, because this is a program in English, so you need to have a certificate that you are fluent in English. It depends on the universities that you choose, the level. The CV, you have to have a very good CV with extracurricular activities like this, for example, is a good thing you can mention there. But I mean, the list is a little bit long just because we have awarding universities, each university with different criteria. But in general, an applicant has to make sure they fulfill the local requirements of the universities they choose. And then if you meet those requirements, you have to go to each of the local programs that they have. Most likely, you will meet the requirements of the program.
Thank you, Catherine.
More details, go to the website, please.
Thank you, Catherine. One last question. Anyone? Go ahead.
Hello. It's fine. I think my voice is loud enough. So, for example, I'm a student who's currently taking my PhD in the Philippines. So the educational structure is a little bit different, but I haven't begun with my dissertation yet. I'm still in the proposal stages. What could my steps be in case other students are the same as me in my situation? If I want to pursue my research somewhere in one of the available options that you presented.
So this question is for Catherine.
I'm sorry.
This question is for who?
Yeah, sure. For Catherine or for any of the panelists.
So if I understood correctly, you are a PhD candidate or student, and you want to know what are the opportunities for the next step in your career.
Yes.
So, well, in Europe, there are many countries. Look for a postdoctoral position. So if you like research, you can continue in that direction by looking for postdoctoral positions. But if you like more hands-on and go to an industry setting, Then you can look for postdoctoral positions in industry, but you can also look for jobs directly in industry. It all depends on what you like and what is that. Yes, I think that's like, I mean, you have to decide which path you want to follow. I don't know, Fabrizio, if you want to add
Thank
something.
you. So, thank you, Catherine. Thank you for the questions. Now, one finale statement from Dr. Fabrizio Gagliardi.
Okay, yeah. Few final, well, not final, few recommendations from my side. So first of all, yes, the UREXA presentation we have seen is a really precious source of information. They issue frequently, at least once a month, the status of all open opportunities for students. I mean, EUREXA exists throughout the world. So this is EUREXA ASEAN. So basically, they do the work for you guys to filter or what is available from European Union, so from the initiative which are funded, you saw impressive number by the European Commission, European Union. They fund also those training programs, and then you have EUREXA in each part of the world. They basically filter out what is relevant for you guys. So that is definitely a website you want to put in your list and go and check regularly. You can also enroll in their distribution list. So you can basically on a monthly. So that I think a precious source. Now, people who are interested in this kind of intense training, I would like to bring your attention to a fantastic opportunity, which by about 10 years is called the Heidelberg Laureate Forum. So you had the privilege to listen and interact with Leslie Lamport. Leslie Lamport, for instance, is one of the 42 Nobel laureates. The last, this year, last September, they were all in Heidelberg, and you can apply. There are 200 positions every year, so 200, it's not, it's a considerable number. It's 200 positions, and the selection is biased towards the Big South. So if you come from Asia, you have better chance than if you come from Germany. Okay, it's worldwide. Students are extremely well treated because that is all private funding, so no European rules, no rules of anything. If you are good, you are taken. No question asked. Okay, and you're extremely well treated. The travel is paid. You're staying in a beautiful hotel, and you are all the time in contact with the laureates. It's not just for computer science, 100% is for computer scientists, 100% is for mathematicians. Because together with the laureates of they are the laureates of the Abel Prize for mathematicians, of the field, I'm looking at you, I'm usually Abel, Lavanilla, and Fields. So you can have breakfast with the field medalist. It's quite fun. You can have dinner with himself, as I normally do, as going to tell you, is how he invented internet, and is the extragalactic is now bringing internet on the space. This is not a joke. It's for real. So look at that. Now you're actually in time to apply for this coming year. So the other Lara forum is always in September, but the application, go on the website, the application ends in February. So you are still in time. That is a fantastic opportunity I'd like to bring to your attention. Then the other opportunity is the macro. That's the school that I invented in 2017, and this is the school that Pierre Wood was mentioning, inspired the school in ASEAN. So when I offer a few posts to ASEAN students in 2018 to go to the school in 2019, something like that, I had the privilege of host, I think, at least 5 students from ASEAN. One of them was one of postdoc of Joe Wood, who, by the way, did extremely well. And in a very competitive environment, he got one of the best prizes, prize. So out of the school, just also to to set that straight, out of the school, we decided, with essentially thanks to Pucha, who was this person that we all miss, we decided rather than let the student to travel all the way from
Excuse me, man. We need to wrap up.
yeah, I haven't finished yet. Thank you, let me finish. Okay, I think it's important.
Yes, we have a hard stop for final prayer.
Can I finish? Thank you. So we decide to then bring the school to ASEAN. And that is what we are now having today, and I do hope that school will continue. I will do my best, but of course, there are many other actors involved. Thank you very much for your attention.
Thank you very much, everyone. All the panelists, Susan and for also the additional information from Dr. Galiardi. I thank you for everyone for the attentive audience, and again, the materials will be shared to all participants here, so they can refer to it for all of you. Thank you, and next I'll head it over to Andrea.
Okay, thank you. And so, because we are a little bit late for Muslims, you can go to outside, and there will be a transportation go to mosque for Friday prayer if you want. And for those who do not go Friday prayer, you can have your lunch here. And for students, you can leave your luggage here, bags or everything here. And for those who haven't signed the present form, you can attendance form. You can go in the reception and take the attendance form. And I would like to have Muhammad Aki Isra Ramadan. Where are you? Are you there? Okay. Oh yeah. You have to take your shower then. Okay. Anyway, and we will come back at 1:30 for a panel about
how high-performance computing and also AI is going to evolve, especially the computing platform. You are a mix of people more interested in the system development, but most of you are more user of high-performance computing system, more interested in application. And of course, the two things go together. Because the technology produced by the major vendors and by the computer scientists, that is the kind of technology push, because they push down to the application, new architecture, they give you possibility. You heard in the previous days, exascale computing. So exascale computing is going to give computational scientists a computational power never seen before, which of course is going to make existing application go faster, but moreover, more important, it's going to open the possibility to new applications that they were not possible before. Because of course, if your application require 1 year to complete, then it's unlikely that you're ever going to keep the system active for 1 year. So, if you move from beta to exaflops, maybe you can do it in a week, and in a week we develop the system. So that is, in a way, is the technology push. So new architecture, new computing power is going to push down the user, the application developer, new possibility. And then there is the application full. So now everyone we're discussing before is talking about AI, machine learning, whatever you want to call it. The fact that this is, many traditional computational science application. We've seen good demos of AI applied to climate model, earth science, general, life science, and those require different computing architecture. The typical double precision floating point or the big models that have been happily using for the last many years, they don't fit any longer the AI application. They don't require double precision floating point. They are very happy with smaller precision, smaller lengths of words. And on the other hand, they require a high level of connectivity, and you see more and more huge GPUs, farms that can do a practical job. So that is more the application full. So if the future everyone is using those kind of a based system for their science, maybe the way in which the traditional supercomputer are being designed need to change. We have here Pierre Wood to represent the system environment, the technology push. So let me introduce the panelists and you understand why is this panelist there. So I mentioned earth science, which is a big earth science virtual computing which are often coupled together because often they share the same model. And the virtual computing is not but the model are often the same. So we have Regina. Okay. So being an Italian microphone speaker, say Regina, which means Latin means so Regina, she comes from BRIN, which is all about weather forecast, tsunami detection, and disaster mitigation, climate models. Okay? So they are big users of high-performance computing, and since you haven't seen her on the podium yet, Regina is going to represent that particular application. They would already said, the companion of many adventure, including the very same idea of starting in school, is the system science, is the technology push. Life science, you see Ross and you also see again, and classes of the two together represent the life science application pool. You mentioned this kind of platform, but also an application. And I mean, we're very curious to hear from Mohamed how we see, Fugako evolving in the future. So now they are thinking with Satoshi Matsuoka-san and Kengo-san. They are thinking what to do after the Fugako, and it will be very interesting to see where Fugako will evolve to take care of AI, or let's say of the AI computing paradigm. So then I think it's enough to introduce the panelists. Well, I don't need to do it myself. I'm the moderator of this panel. I'm very pleased to do that. So I would like, the structure of the panel is the following. I would like to start with a short, no slides, a short introduction, opening statement by each of the panelists. Then I will open the floor for questions. So think about asking questions, put them in a bad position. And then after the discussion, I hope it's going to be lively, but I mean, with the brilliant people like you, I'm sure, no doubt. Then I will try maybe to draw some conclusion and then pass again the mic, the word around the table for a final concluding remarks. So if you're happy with this agenda, why don't we start? Okay, so basically tell us. Okay, so basically tell us how do you see the evolution of your application impacting the platform. Now you're using, let's say the conventional supercomputer, actually. So let's say in 5 years' time, with your anticipation of the development of your application in the next 5 years, what will be the requirement of the vendors in 5 years? So do you still buy the same computer simply faster, or do you think that you bring everything to a GPUs or whatever? So what do you think, PIU should provide in 5 years?
Okay, thank you, Fab. Well, from the earth sciences point of view, we have so many applications that are running on CPU-based HPC. Basically, the WRF, WRF, and then used for meteorology, climatology. They usually use WRF. And then the couple atmospheric weather ocean model, and also the geophysics model like tsunami, compound, they're basically running on the CPU. So, but we all know that the investment of CPU, HPC CPU is very large compared to GPU. I mean, maybe it costs 3 times more expensive to buy CPU than to buy GPU HPC. And also it requires much more space, much more power to host the CPU system. We all know that we are going to the AI era, and then also the more dense infrastructure to be put in our office. So we are fully aware that all the CPU applications basically need to be ported to GPU. That's why on Monday I talk about how to port the applications, because most of them are still based on CPU codes. So foreseeing within the 5 years,
we believe that we invest more in buying the GPU machines rather than CPU, because sooner or later we have to face that GPU offers faster computation than CPU ones. And that also implies the requirement of the people. We have to be able to, to program, to port the codes. That's why, we need the capacity development in the terms of area. And we intend to send our people to have more trainings on that. Maybe that's for the science. Thank you.
Yeah, I think it's a good introduction and actually a good confirmation of the programs in school. That there was a specific training by the NVIDIA people, including CUDA, and especially the way in which to program using AI. So, from your side, with Earth science, urgent computing, there is definitely a need to see an evolution toward more use of accelerator, GPUs, and again, the potential impact of AI, which could change a little bit the paradigm in which programming, and of course, because you don't program GPUs in the same way you program conventional CPUs, you need to train the people. So this school already is a good contribution because we did address with the vendors the specific need of graphic accelerator units. Okay, well, it's quite handy. You are on my left, and you can already maybe respond. What is going to be the next system?
The first system is to pay off the debt. All right. Anyway, that's good. Part of the job I'm running the service at in Thailand, as I mentioned before. But it exists one thing. I wasn't trained as a HPC or computer engineering, and not in terms of technical expert. But anyway, I'm taking up the system science part. Well, first, I think good news related to the applications. Last night, when I was preparing the script, I turned on the television in the hotel. There was a channel that last 1 hour that's recognized the computational power increasing in the use of environment and well-being. It particularly says something about this, bad weather, PM 2.5, things that then with the computational power has been increasing like beyond the months before. They can do more on this modeling and how to respond to this. So in a way, the good news is that awareness, the linkage of HPCs and the effect to you in terms of social and economics is there. I wasn't paying attention, but I was so surprised whether the schools on live television to launch the program or not. There was a lengthy interview with a lot of people also from Singapore and from Myanmar. So the first response, so at least I think we got awareness. Okay. Second thing is, I think the theme of this is called the future of HPCs. Myself, no, not a visionary, but I'll do my best here. Not on my own visions, but a month ago, I interviewed you and maybe a few others here was in Denver at supercomputing. A few things takeaways of a trend of HPC, at least in the 5 to 10 years from now, that I can say from my observations. First, GPU, as you mentioned, is growing stronger, and we have seen one couple of directions that the CPU and GPU now will come in as a single board. Yeah, example like an AMD APU, which was said sometime year ago, and NVIDIA Grasshopper. Yeah, so that would be a trend, which will certainly come along with another burden of how to get rid of the heat and other technology seen more options available at ASEAN as well. The other major trend that I need to point out, I think the HPC cloud now is, I think it's going to be real when it comes to be very mainstream. Announced by 3 large cloud service providers, AWS, Google, and Amazon. There are 3 big booths over there. It has clear statement that HPC cloud is going to be things, let's say, commercially available. We have struggled with this when the cloud coming up earlier, and HPC and cloud linkage has gaps in many aspects. Okay. And also, the new machine number 3 in the world was from Azure, Microsoft. Right? Another trend I say that perhaps help with what you mentioned. I see that more development and pay attention in terms of more GUI user friendly, so that the user can get more interactive into the HPC system. Okay. Well, it's not perfect. I will not say it here, but I see that one is doing better than the other in terms of user friendly experience. But let alone, so that refer back to maybe the first day when the guys from ASR mentioning supercomputing at fingertips, which I've been saying a concept for 5 years in a row. Now you start seeing product and things that are going to help you toward that angle. So not only the GUI to manage the systems, sooner or later, there will be more GUI, more user-friendly to help with even the user application. I think that's a trend that I have been observing. Okay. All right. 4 minutes. I have 1 more minute like this. AI. Touch on AI. I think AI and HPC in this way are some biases. Exascale will push more on applications that have never been done before, but AI will also get much smarter really quickly, and AI will make demand for more HPC. So these things grow together for quite a number for a while, I guess. Touch upon another thing, quantum computing. I'm not sure whether I should say that, but yeah. My personal view, this one, okay, it will come. But also my personal view as well, I don't think you are going to see the application that was written, tangible result in the application that we are pretty much touch upon our life in 3 to 4 or 5 years. It's still very much on the research and development of the developing stage. So my concern was that, well, when it comes, you don't want to face something we had in terms of when there was 2 decades ago, software industry was so booming and you saw lacking human power, human resources to do software development. Quantum computers, I would say, put more effort on preparing people when the technology is coming. But in itself, ROI should not be seen in 5 years at least. Now, talking on this one, well, I think I drop here. Maybe second round. Thank you very much.
Okay, hi everyone. This is a very broad discussion, so there's a lot of aspects that I think are very important to be touched on. So first of all, for life sciences as a domain, it's super broad. It's very big, and if you look at the different scales of that we study, and they fall in the category of life sciences, they're so different from one another, starting from the molecular structures, atoms, going through cells. Then if you look at the organs, the tissues, the whole body, and the human, then look at the whole population, the application areas, the software, the methods, the algorithms are all different. And they have different requirements and needs in terms of compute infrastructure. In some cases, you do a lot of modeling and simulations. In other cases, you have to process vast amounts of data. In some cases, you work with a lot of similar data. You have to process in batch mode, and in such cases, it would be very okay to run on a cloud or a high-throughput fashion. For some of the simulations, you really need as fast and as big machine as possible. AI is penetrating the domain very strongly in other disciplines for which you also need HPC to train the models. So life sciences is one of the biggest beneficiaries, the biggest need of any future development of HPC. Then one thing regarding the increase of computer speed and what we do with it is that we need to put effort to port applications and be able to use efficiently these machines, because once we get used to the speed of getting the results, it's very difficult and unimaginable to take a step back and go to a smaller cluster. Like if, say, you get to drive a Lamborghini and it's your car for a week or something, and it's fast and smooth and nice, and then you feel really disappointed if you go back to another car. So with HPC, it might require effort on your side to port the code, but once you get there, you don't want to turn back. There are some domains in life science which for which HPC will be crucial. For example, urgent computing in terms of personalized medicine, precision medicine. Say when a patient comes with a tumor or some other disease that you need to sequence it, do the social alignment, find what's the mutation, check which is the best possible plan of action. If you just have one or two patients, it's fine, but imagine that everybody in the world who have this urgent need, is that they need to have access to large scale resources to do that. Then we all agree that applications should catch up with the hardware development as soon as possible. So the moment you get a new chip, a new system, you should be able to use that at the full potential as soon as possible. And often in academic settings, the research groups sometimes they don't have the expertise to do the porting optimization, or they don't have the capacity. In science, you're rewarded for publishing cool papers, high impact journals of discoveries, not papers that you ported to a new hardware architecture. So the incentive of spending the time and money on doing that is not obvious right away for the stakeholders in the whole field, including also the funders, the national funding agencies, other organizations are trying more and more to invest in the development of skills in the research so that they are able to optimize their products for the new systems. And then, in general, the impact of HPC on industry, we often get the question of, like, well, what is the impact of the software that you develop? And when you talk to industry, it's like, actually you turn the question the other way, like, what is the impact if we didn't have these tools again? Well, we can't do anything. It's like doing experiments without flasks and test tubes. So yeah, maybe I'll stop here. There's more stuff.
Okay, thank you. Hello. So the Rosen-san told about the very broad point of view of the life sciences. So then, but I'm one of the developer of the molecular dynamics software, as I told yesterday. So then I would like to talk about a more specific point. So then, as for the molecular dynamics simulation, I think many of you already know, so we as a molecular dynamics simulation utilize GPU so well. And every software you already use the GPU code, and yeah, of course, Genesis, our software also has a CUDA code. Yeah, the GPU is quite important for that, because molecular dynamics simulation requires so huge computation in order to get the long trajectory, it means the molecular dynamics. Then, yeah, so in this sense, so the molecular dynamics field always requires a high-speed computer. Then, if once the new architecture came up, everybody goes to this one. That's historical related to the molecular dynamics field. However, it's quite difficult recently. You know, so the new architecture requires a new program language or new architecture, and so then that technique is so highly sophisticated. So then, yeah, but so you know, so the biophysics field, many of researchers was measured in the chemistry, or physics, or biology. So then it's not so high HPC person. Then that is quite a big gap I saw. So then, yeah, of course I know I work for the molecular dynamics development so almost 10 years. So then, yeah, many students love to work for the molecular dynamics. However, don't like the development. Yeah, so then I try to talk about the please join the development. So then, yeah, you can get a good position or I don't know. Anyway. So then, as for the AI, the new neural network issue, as for the molecular dynamic field, also these techniques are already popular. However, so these techniques require so huge computation in order to get the data. So then, yeah, someone may tell that we don't need to molecular dynamics anymore. But no, we need molecular dynamics more. So then in this sense, yeah, that is my point of view. Sorry.
Okay, so I think now our friend Mohammed has an interesting challenge, because basically you've seen, everyone has been mentioned AI and the impact on their computational science activity. We heard, a strong word, a warning from Leslie. Basically said, well, there are various ways in which AI can evolve. On one end, it could be just us, the humans, really defining the problem in words which are human words, and then letting the AI to develop, eventually write the program, come to a solution in a kind of a black box way, so the way that we'll not be able to really understand what the computer did, so we don't really satisfy. The other side, the flip side, the positive flip side is it might be it might work in a different way, where you still have to think strongly about the problems, write maybe the problem with the pretty precise technical specification language, and then let the AI system take the specification that you have written and then do the coding that we all understood Leslie doesn't like to do. We like to do programming but not coding. So that is basically what I retain from Leslie. And what is your take in how AI is going to be developed?
Okay, so should I answer first about the AI or about how systems will look like? Okay, let's leave it. Okay, so first about systems, just to have continuity of what previous speakers in the panel said. So think next generation systems, and that's about 5 years from now, plus or minus, will be very different. We're at really a crossroads. The reason is, historically, HPC has been a very small market. At best estimates nowadays is 20, at best $30 billion a year, which you think is a lot, but then think of it like Apple gets more billion selling iPhones in a month than that, so that's nothing, right? If you compare to the large scheme of things like clouds or mobile, it's small. Right? It has always been and will always be its niche. It's like Formula One cars, right? It's not like manufacturers who make engines make money out of it. Just a way to subsidize their research so that they technology later on for consumer. Anyway, so historically HPCs had very like people who design systems, people like Satoshi, for example. And they would always acknowledge that you don't have enough market share to be able to get the vendors. Vendors mean people who make memory, processors, storage, and so on, networks. They will not make systems for you. If they make it, will be very bespoke, custom system that's very expensive. And then it's just very hard. So what they did is they historically have always looked outside HPC. They had an eye for technologies that were not at all intended for HPC, but they recognize the value. I can make 3 examples actually, the last 30 years. In the 90s, like up to the 90s, 80s, early 90s, like there were vector machines like Cray and so on, supercomputers, which were designed for these kind of systems. Some people, smart people realized, you know what, they can just pick off the shelf CPUs, Intel CPUs, slap them together, and the name was B-Wolf cluster. And this was a new, incarnation of HPC systems that are made up of off-the-shelf components. And people departed away and those virtual machines died away. This is an example. They took a technology, said, let's adapt it. Of course, over time, those off-the-shelf components themselves evolved. They had more features. They beefed up their capabilities so that they become HPC worthy. Another example is GPUs, actually. Up to 2008, it's not like GPUs suddenly came into the scene as AI. Up to 2008 or 7, GPUs were just gaming, cards, right? You just buy them, put them in a discrete graphics card, and you just play your game. They didn't have floating point units, so you cannot crunch numbers, right? Because you don't do floating point, computations in graphics. They didn't have even ECC error correction for memory, which means you get bit flips, but which affects your accuracy if you're doing computation of high precision, but you don't care for gaming, right? And then 2004, circa 2004, maybe 6, some, again, people in HPC were like, you know what, we ran a dead end with CPUs, are expensive, we need something cheap, and we also want something more power efficient, right? And they looked at GPUs, they found that GPUs at the point were so cheap. Now they're more expensive than CPUs, now they're so expensive, right? Like, things have become different now. They were so cheap, they didn't require a lot of power for memory and power for power performance, but they just didn't have the software stack. And a company at the time we maybe heard about, NVIDIA, just making gaming cards, kind of pivoted, said, yes, if you guys are interested, we can build stuff for you. They made CUDA, programming language. They started making ecosystems, making libraries like cuBLAS, cuFFT, cuSolver. And they started adding stuff. The very first generation in the line of high-performance computing GPUs from NVIDIA, which was called Tesla, by the way. Now the entire product line is called Tesla. But the first one was Tesla, 2008, which powered the Tsubame supercomputer in Japan. It didn't have proper floating point units or ACC or any of that. People took a bet from HPC, said, let's bring this along and then we build. And then was an industry partner that had, kind of view forward, they built up, and it paid off for NVIDIA because when AI came, they were ready. Hey, we have software stack. We have those nice devices. We want to crunch numbers. We're in an excellent position to do that. A certain example is ARM processors in 2014. When I first heard that, internally, I was at Freakin at postdoc, 2013, that they are building the next generation system to be fastest in the world. The name wasn't forgotten yet, we didn't know the name. It was just called post game, the computer app. Okay? And then I heard from someone else going to be based on ARM. I was like, what? ARM? By the way, guys, do you know where ARM processors come from? Literally, cell phones, that's it. It's a company that makes cell phone processors, and also they make processors in everything. Probably in your vacuum, in your microwave. They don't make even like PC level processors, not to mention HPC. But people took a bet that this is power efficient processor. Let's take that and just build the stuff. right? And the rest is history. They built a big supercomputer, and now even cloud vendors, like especially Amazon, has a forced iteration of ARM. So to summarize, HPC has always had an eye for, because we knew there's a small market, take external technologies, adapt them, bring them to HPC, and then become mainstream. Now there's an inflection point. Now this time it didn't happen. It's not for lack of foresight, but things move fast. This time there's market forces that move AI so fast. Now, instead of HPC for the next generation system sitting inside and let's take technology X or Y or that, it's more like, no, things are heading in a way, and you, HPC, have to adapt. I will mention 3 key technologies that in the context of our feasibility study for next are very hard issues for us. One is precision. HPC, I always assume we have high precision because in numerical methods, you need those high precision. We always took it for granted. But suddenly, because market forces, vendors capture more AI market, it's a bigger market, they don't care. I mean, you want MP64, I will not put it for you, I will put it at very low performance because the money is in MP16 or MP8 or much lower bits, right? They even left the IEEE standard. So the GPU that's DFB, I mean, it started from, I guess, Google's GPU is bfloat. It's a format that's not IEEE standard. NVIDIA also has something called TF32, TensorFlow32, which is, by the way, 90 bits, but they call it TF32. So now we're at a big point, an issue that the next gen systems, if you want to buy something, you will not be choosing an HPC. You're confronted with the reality is you have to adapt to lower precision. That's a big issue. You ask yourself sitting here, why do I care? Well, you care because your application will run on those systems. So you have somehow to adapt. You have to figure out it's either going to be solved at the level of system software, trying to emulate for your hard precision or recover or something, or, and probably this is the case, you have to invent algorithms and find ways you work with lower precision. So precision is one. The second, I would say, is matrix engines. What is a matrix engine? So processors typically can do vector operations. Like, instead of adding a number and a number, can take 2 vectors, right? In CPUs, they have what they call semi vectors. GPUs are actually vector machines, right? They are designed for that. In the last 3-4, since 2017, we've seen what NVIDIA called initially Tensor Core. It's a matrix engine. What does a matrix engine mean? It means instead of applying an operation on scalars or vectors, it applies on matrices. It's so fast. There's many technologies that can implement this. The most famous one is called Systolic, but I don't want to go into technical details. But in the end, think of it that you have an accelerator within your chip. Whenever you multiply 2 matrices, you just send the matrices and it does it very fast in a power efficient way, right? And nowadays, almost every single hardware out there in the next few years will have matrix engines, CPUs included. Intel has already SME, ARM has MX, IBM CPUs will have it, all GPUs probably has it now. So this is the second type of thing we did not foresee. You ask, why specifically matrices? Because if you remember, AI is formulated in the end as matrices operation, just multiplying matrices together. This is the second, change in the hardware landscape that HPC has to realize that whatever comes up next will prioritize having co-processors for matrix engine. But then the question, what do you do in your application? What if you're not multiplying matrices? I don't know. Like they say, if you have a hammer which needs a nail, if you have a processor with a matrix engine that is very, designed and geared for giving you all the performance there, you have to formulate your problem in a way that looks like a matrix multiplication, and this is hard. Third feature, key defining feature is memory bandwidth has been always a bottleneck in HPC systems, and if you're by bottleneck meaning that no matter how fast your compute gets, okay, you're always delayed or you're always late and waiting for data transfer from memory. Only exception actually is dense matrix multiplication, MD, because it's n-body completing forces. Those are the only exceptions. But for like maybe 80 or 90% of HPC applications, it's memory. New technologies are coming in again because of AI, something like processing in memory, which processing things in memory. So to summarize the key points, HPC has so far been in its short history of 30 or 40 or maybe if you accept it, it's more like 50 years or so, has always been smart at taking key technologies that big, making something out of it that maybe become mainstream even outside HPC later. This time is different because of how things move so rapid on the front of AI. For the first time, we're not choosing, we just have to adapt. And three things we have to adapt to, not as people who design systems, even application writers, people who write software, that you have to realize that lower precision matrix engines and different type of memory technologies would be in systems. And I fear likely this might happen, that people who design systems and system software compilers might not have the means or time to even handle solutions. So they will throw it in the lab. Hey, we have a nice system, go program it. It's your problem, figure out a way. Likely this will happen because we have a very short time, right? That's for HPC what I'm going to change. I can stop here, we go around, or I go on with AI. It's up to you. Yeah, okay. I agree with Leslie number that having no guardrails whatsoever, telling an AI go do something, come back, this is not going to be acceptable in scientific and engineering fields. Certainly not in mission critical ones, if you make design a drug or a battery or something, and also even in science fields like say astrophysics or whatever. It also will not fly because you have rigor there and you will not accept these results. Now the question becomes, if you accept that you would use AI but with some harness on, what does this harness look like and how do you make it? Is it possible or not? This is a very hard question. I guess the starting point is to approach it with a slightly different mindset and not treat it as this black box. It is black optimization, and black box optimization is actually a technical term in mathematical optimization. But people nowadays use black box as if it's just a generic term to mean this is something I don't know how it works. It gives me back the result. Okay. The question becomes, how do I approach it without this black box mentality? I think actually we do have figured out historically how to do it. If you just take AI out of the equation and put statistical model, I think the mindset changed a lot. So for example, every single drug you have taken in your life since the first vaccine you were 1 month old to the tablets you took last week in the stomach, they were delivered to you after being approved by regulatory bodies that use statistics to approve it. It's not like you took a vaccine, you tested on every single body in yourself. You tested it in some population, they have a system for that. And based on the statistical results, they approve it and push it on. So we have systems like that already. It exists. A lot of other examples. I mean, when you drive a car or whatever, the inspection of the quality control of the car, you use statistics. It's not like they test every single piece. They don't have the time or means or slow or expensive. So somehow in many key areas we have managed to work with a system where you have statistics and statistics. And nonetheless, you kind of progress, you didn't stagnate or stop and say, well, this is not exact, this is not deterministic, this is fantastic. People found a way. And that's in a lot of fields. The issue with AI, I guess, is that it's not defined in that way, just defined as a like we're working with. So if it's approached in the way that it's just a statistical model, we have developed historically and we will continue to develop ways to harness and control. You can't just use it as it is, of course. You need, for example, uncertainty quantification, putting bound, stuff like that, where you can rely on it. Nonetheless, it's something that you cannot fully understand or fully measure. People have done that. So what's new here? I don't see the point. Just that we are thinking it. So every time myself I should remove it, it's a statistical model. Last example I'll give, generative AI. People fear generative AI. What is generative AI? It's exactly statistical inference. Think of it this way, a very simple example. You have a Gaussian distribution. It has an equation, we know it. Thanks Gauss for that. Let's say you don't have. Let's say you went to some AI, some model, and you showed it a lot of points, right? That happen to be sampled from a Gaussian. But let's say you don't know the distribution, you don't know the equation. What is generative AI? You're just showing it a lot of points, and then asking it in the future, give me a new sample, a new point, that based on what you have seen, is within that same distribution, that you as an AI don't know, and me as a human also I don't know. That is generative AI. You can think of tons of examples already in science and engineering where we do something similar. Exactly in distributions, by the way, where we have a phenomena, especially people who do high energy physics, where they have a phenomena, and they try to study, and measure events, colliding particles, and these are distributions. And based on that distribution, they try to make science and understand it. So I think overall, it's not so bad. You just need to understand and it's not something new. It's just on another level. It's very, very, it's just qualitatively much better and very different, and we don't understand. But if we approach it in a way that we are being comfortable working with stuff we don't understand fully or we don't know, I think people over time will just develop methods. Not in every field, but some disciplines at least.
Okay,
We're taking more time than ever.
Yeah, no, that I think is it's probably a good introduction of the subject I wanted the panel to address. So we have seen that you are really lucky to all of you are starting a career now in the next immediate future, because you are living at a time there's so many things happening. We've been I've been over my last many years of activity since this current evolution. The more law every 18 months a year you get more processor chip density, think improve, performance improve, life was easy, and essentially the high performance computing was dominated by big critical application, very much the defense, the military, and basically pushing the vendor to develop new machine, but in a market which was always some kind of niche market. There was a time in the 80s where we said, okay, well, it's difficult to continue to push the performance single processor. We need to go massive parallel. And, and we try to simplify our life as programmers and say, okay, massive parallel, just sharing one memory. It was the time of the huge shared memory system in the thinking machine, Mako, CS2 in Europe and so forth. But then, then the market pressure, what is sometimes called the killer microprocessor. Okay, so generic microprocessor using not a huge shared machine, using their own machine. So basically, people have to, it's this kind of mutual process where the application are driving the technology, but the technology is also imply people to change the way they program. So we learn how to program in a clustered way. So cluster became the conventional model. Now supercomputers are programmed like clusters. Now we have AI, which is kind of like, we always had AI. Now AI has reached a point where the technology makes it real effective. So we have AI, HPC remain niche market, so it's very difficult to make money out just building double precision big computers, which remain critical for some of the applications we heard. You cannot do without it. But what is going to happen? I mean, if you look at the entire food chain, the entire resource chain to build a supercomputer, you need to have Americans. The Americans dominate the processor design. Okay, Japan is not bad either, but I mean, it's dominated by Americans. Then at the end, I mean, America only now with the US Chip Act are starting to invest back again in major fabrication, so really to fabricate, to produce the processor. But today, the processor design in the States goes to Taiwan with a single company, the SMC, who produce the silicon, and by the way, produce the silicon using European technology coming from the Netherlands. So we are in a very fragile system, governmental worries, and people are thinking of alternative. And also this, you have to factor in what normally are called hyperscaler. We are mentioning Amazon, so Amazon, Google, Microsoft, even Alibaba, you name it. And those people are developing specialized processor, tensor processor, really for AI application. And those people are so big, they produce an excellent processor. They don't send it to us, the science. We cannot buy the processor from Amazon, from Alibaba. It's part of their competitive edge. They send you the application, so they send you the services, they send you, a large machine training system. They send you that, but they don't send you the processor. So that really changed the way in which we operate. Because if we try to design the next supercomputers, we will talk to some vendors, but the vendors will have a hard time to deliver the system, acquiring in time all the necessary processors. It happened that some systems were late. I think all the systems I've been dealing with in the last 5 years have all been late. So it's a very, very interesting world. I don't know in which way it's going to develop. Because on top of that, you have to take into account, the political environment. I mean, government now realize that if you want to protect your economy, your country, your health, you need to be on top of this overall development chain. You need to have the technology, you need to have the software, you need to have the engineering. So back, someone, I think it was Regina was mentioned the importance of training. So that's why I hope that this school is going to continue and without, not with 80 students, but 800 students, and not every once a year, but every once a month. Because at the end of the day, it's the human factor. You need to evolve the application, you need to evolve the technology in a world where the market forces are not necessarily playing in our favor. Who is going to develop another super Fugaku if it's not going to become receptive? In the meantime, the hyperscaler can say, oh, come to us. We can train your system very cheaply over the internet. Well, until maybe a boat drag an anchor across the Baltic Sea as it happened 2 weeks ago, and all the cables are backed. Just think, in 10 years ago, the things were not happening. We were all a nice global village, and now, so interesting word. Maybe I took too long, but I really now really listen to what you think. So, what are the questions? I mean, again, fantastic opportunity. Also, as expert in the same place at the same time. It's not easy. So, profit of that. So, what is really come to your mind as a first reaction? Who want to start? There is a special prize for the first question. I don't know what it is, but I will buy it at the Okay, you will do it. Yeah. Yeah, somebody,
Thank you very much. I'm Lina from Indonesia. So I'm working on life science. I'm in the life science area. So I'm working on RNA-seq data and then genomic data, and now working on a protein genomic 3D reconstruction. So when I work on RNA-seq and genomic data, it's less than 1 terabyte usually. And then now when working on protein, it generates like 4 terabyte every project. And then HPC has really helped to actually transferring the data and then process the data. My question is how to choose the right software. I mean, one software using the CPU with the MBI, a lot of CPU, but one software using a GPU. So I'm still thinking whether or not, because our facility is still heavily using the CPU base, and then whether or not we need to buy the more the GPU to actually working on protein. Thank you very much. Or maybe there's a suggestion.
So, GPU versus CPU, which one to choose for your department, right? So you need to see the application which you are using, how well it runs on GPU and CPU. Some of the codes publish actually studies and benchmarks of the performance, not only in terms of speed, but also in terms of power consumption. And especially for large centers and machines, the cost, the kilowatt per useful unit of work is more important than how much it costs per processing. There's now a lot of work being done on energy efficiency, because in some cases you can run your application slightly slower than the maximum possible amount, but and you will get your results maybe not in 10 days, but maybe 15 days, but you save a lot of money because of this slower execution. So the recommendation is that have a look at the specific code that you use, whether they have published benchmark data. If they have not, then do you yourself, small study, you run on your CPU, you run with 1 GPU, 2 GPU, it depends what you have at hand. And even, because also it depends on what system you have access to. So you may see a benchmark that says, oh, do this and that, but you don't have access to your system, so this is maybe useless to do a state. So it's always nice, you will also learn a lot in the process of doing benchmarks yourself, especially when you will be using this code, these methods for years to come.
Yeah, I really agree with Jose-san's opinion. Yeah, benchmark is quite important. I told in my lecture. Yeah.
Thank you for the opportunity. Maybe it's not a question, but more like my own opinion. It's interesting about the development, to which way, which direction the development of the HPC in the world in the futures. But I think for me, I'm from engineering background and I have few experience with development works that not everyone that works in the background of engineering has been exposed to HPC, especially in, where I work, obviously. So you mentioned that there's a struggling, there's a challenging in the development of the in the future of the development of the HPC. So what I guess one thing that can be done is actually provide services to make the existing HPC more accessible to everyone that works in the, especially my background engineering, classical engineering. Like what Ms. Regina said, some application that we use is based on a CPU application. We don't know, or maybe there's already exist the applications that we use that work on the GPU, but it takes time to like working on the application to be working with the GPU. As for myself, I prefer to be called as an end user, so I don't really care about in which part of the HPC that my applications work. So this kind of services could help us. So I just can give okay, this is my algorithm, this is my code. Can you run in your HPC but make it as efficient as possible? So that's your third party business maybe. So I just use the service to use the HPC. I don't see that this kind of things is explained in these schools today. So I just want to point out that things. Thank you.
It's now coming live, yes. It's an excellent, yeah, that's what's the word. It's an excellent observation, so the programmability. So, well, I don't know because I'm not in that domain, but I mean, do a kind of workflow or see workbooks or help so that and eventually, so you describe in a high level your program and you leave the complexity of the program and the understanding of the underlying platform to the systems. That's something that certainly uses and approach workflow to take care of. You still need a lot of knowledge about it.
Yeah, the short answer is no, it's not reliable at all. I mean, if you use AI in your code that you did, but as a surrogate model to train data, so that's one thing. You have to ask AI, hey, write code for me. There is no cognitive correctness whatsoever, right? There are ways where it's okay if you're prototyping, we're learning a student, get rid of this function, take it, run it. But to inject code generated from AI into code bases, that's basically at least at the current form of AI nobody should do it. Nobody would do it actually. Our efforts, though, to even in my team, to try to generate code or produce code at a level that can assure correctness. So for example, if you write codes that have loops, and loops are control structures in any code. And those are called hotspots. Like hotspots in your code are parts where most of the time spent execution. There are ways where you can then transform the loops or change them, but assure correctness. And this is where AI can be used. But just openly describe your job and AI takes care of it, that's we're very, very far from that. Yes, you can do, of course, but there's no assurance it can hallucinate and generate anything for you. And then the time for you to make sure. There's a famous quote from Dijkstra, the famous computer scientist, great fame. He says, I'm maybe rephrasing, I'm not sure exactly, but it's along the line of unit testing can catch bugs, but it will not tell you if your program is correct. One approach I see about, for example, there was a paper by DeepMind in Nature a few months ago, and they said we discovered new sorting algorithms. And what they did is they took a computer program, broke it down to instructions, and they started, resorting the instructions to make it more efficient. If you look into the paper deeply, they said, yeah, we just use unit testing. Unit testing, if you're not familiar, is you take a program, you test it with different inputs, and see the outputs. Of course, that's not a reliable way to get software, but it catches some bugs for you. It doesn't tell you your software is correct, unless you test it with all possible input values, which is basically impossible. So that doesn't exist. So I guess this maybe answers your question.
We're not trying to make AI for the code for us. But like when using the HPC, like this previous day before the lecturer challenged us to give to make a code that code works like efficiently in the HPC, like using all the cores and using all the powers that the HPC can give you. But as the end users, maybe it's quite a task to handle. I mean, we're already busy thinking about our code, let alone to be efficiently use the HPC. So I think there could be a third party that provide that kind of services to the end users, so the end users can focus on their code without too much attention to the.
So what you're describing is basically being a helper for you, a utility to make you more productive.
Yes,
that's
mostly advanced
helper.
I think.
Those tools already exist, right? So like profilers and such. So you would ask, okay, I want to do more simple. I don't want to learn profilers and do detective work like this, nice tutorial that had 30 steps, right? Literally 30 steps. But the question would be, how would you trust what they have? Because it can generate anything. It might tell you, oh, you need to do X and Y, but X and Y is wrong. How do you make sure you go and test it? Then it defeats the purpose, and it's not helping you anymore. It's getting in your way. At least when you went step by step using tools that are established, you are getting correct feedback, and you're optimizing that. But with AI, I'm not sure. Might it work? Maybe it's a good day. Might not work. Maybe it's a bad day. So it's up to you to decide whether I rely on something that has zero, even if you literally go to ChatGPT, it's written down there. We do not, have disclaimer, we do not guarantee that anything here produces is correct. Even if it sometimes looks all very accurate and correct, and sometimes it's helpful to ask something fast. But nonetheless, we are speaking not about I'm prototyping for learning on my computer and playing. If you're speaking about HPC production codes, stuff like life science, molecular dynamics codes, this is stuff that's used in production. Then you cannot afford to do that. For the time being, at least. I don't know about the future.
Just to add on this one, strictly speaking from the management of infrastructure service of HPCs, as a last resort when all else failed, and strictly non-AI related, no AI domains. This comes to the people interactions. As the service centers, we have, I mentioned on the Monday, I have a team for scientific support, which actually is supporting the user on applications. And the fact is that nobody knows everything. We have a case, simple you cannot optimize because a certain code, looking at things solve in about an hour or two. And we have a case that take together a month because we're not familiar with them, you're not familiar with them. And we have to also, as centers, we ask around for another collaborating center. Have you ever seen this case? Can you make this one more? How come this piece of code or this application doesn't run on the rest of CPU? Why does it run on the 2 cores? Yeah, or something like that. Okay, so as a last resort, the HPC centers, service center, has to design your service to accommodate this last mile when all else fails. When they're profiling tools, AI tools, and things like that, when all that doesn't work, it's up to the people. So when you join this family, it's not like a go to department store purchasing thing and again sometimes it's not off the shelf product.
Okay, so I want to leave some time for our panelists to wrap up, but there is still time for a couple of common questions. So, okay, there is one. And I like it. You are an active audience. I like that. Great.
Okay, thank you. Hello, my name is Samsuri from BMKG. So in BMKG, we are running model for weather forecasting in HPC. So I have read about the hardware recommendation for the weather forecasting model. That this recommendation for the optimum process of weather forecasting to finish. My question is there any suggestion or recommendation that in hardware terms that can make the weather forecast that we run can be more faster running other the recommendation that we found in the I don't think it will recognize to answer because I don't really have in but perhaps another team or maybe I mean that I have heard that we should change the code, but I'm not the one who in charge that, but I'm looking for the possibility for hardware configuration that can improve the weather forecast to run it more faster. Thank you.
To whom you would like to ask?
Perhaps another panelist other than Ms. Regina, sorry.
Okay, so the question, and I guess you can generalize, you want to make it work faster. So the unfortunate reality, and there's no escape from it, you cannot do high performance without understanding the system and doing the hard work of going through your code and working on it. Have you, for example, I always a good example is look at the normal car. How do you interact? What is the API? What's the interface to a car? Steering wheel and some pattern, right? It's pretty simple. Okay, have you seen a Formula One car steering wheel? How does it look like? Tons of knobs, tons of buttons. You don't know what they are. A similar example is a plane, cockpit in a plane. It's a big dashboard because again, it's a high performance machine, high performance flying machine. In Formula One cars, high performance car. So if you want high performance, there's no escape from seeing what's happening. If you really want to tune and get high performance, there's no other way around. You can't have both. You can't have high performance. I've seen a lot of people going down that road. I want high performance, but let's abstract everything away. Let the user write equations and then it runs. In narrow cases, yes. If you say, I'll take a specific exact application, I will restrict the user. This is a library for exactly saying logarithm dynamics. And then people behind the scene are doing all the effort to optimize for you. But then you restrict it with this library or software to do exactly a small set of functions. Outside it, you can't. But if you speak about the general purpose code written in Fortran or C, right? Maybe use some libraries, but generally you're writing all your software, right? And you're not using a specific software. Then it's up to you. The system has to be exposed to you, and you have to optimize for it. There's no escape from that. I hope there was. I don't see it. And the way to do that, that's a reality. The way to do it is just to engage with experts. Have to have someone in your team or someone you collaborate with who's experts in HPC. Most HPC centers have teams, ops team, and training teams to help you and navigate how to understand its state of practice, and how to profile your codes, how to understand your codes, how to optimize your codes. That's a hard way to go, but maybe somebody else has a different idea. Thank you.
Yeah, I completely agree with that. There's no other way. If you want HPC, you need to put the effort. If there was a way that it's automated, it's a black box, you just push a button and you get the output, somebody has already done it. And it won't be interesting. It's already done. Yeah. So there will be always, no matter how much you optimize, there will be always something better.
Okay, I think have the comment here, please.
Yeah, to add with answer, yeah. There's a way that for us to see the code as a black box, we need to understand more. I know that there's a model in BMKG who runs multi-core, multi-nodes, but some models, including what we use, it's bound for certain number of nodes. Yeah, no matter how many nodes or cores we add to run that model, there is a maximum cores. And that's the what you say, that's the maximum that the model can do. You cannot add more nodes to speed up, to increase the performance. Yeah, it's the maximum of that model, the maximum capacity of that model. That's why. And there is another model from geophysics that I know that it can only run on single node. So no matter that BMKG has 372 nodes, we can only make it run 372 times for that single node model. So we need to otherwise we have to change the code so that it can run parallel and it can be we can maximize the performance. Maybe that's for me.
Okay, very good. So I think we're at about 15 minutes left. So I really would like to have the panelists to draw some conclusion from this discussion we just had, and basically that we wrap up. So.
Okay. So bring it, and also bring it back to touch upon us on ASEAN, as I know that some of us are BRIN, and maybe BPG, and also a few other institutions sponsoring being up at HPC centers. Okay. Russell bring up Lamborghinis. Yes, and it is true. HPC, you can have Lamborghinis. Once you run it on successfully on Lamborghini, you want to go back. And I can trust that whether how it's going to go in the future, Lamborghini with the model more effective models. But what will come with the Lamborghinis come with more gas guzzlings, fuels, and the pain point of the public HPC centers. Okay. Not only me, I have been talking around. Now, people who are above you that start talking about, hey, can you help pay for the cost of the fuel that you are running, consuming, regardless of performance and better, it's increasing anyway. And the cost recovery has been starting to be a deployment on KPI on the public HPC centers around the world. Okay, so take that into account as well. That's one thing that I want to put on. And putting aside, doesn't matter whether how the landscape HPC will change, and including whether that the new generation is coming, whether the new Lamborghini will look like. For us in ASEAN, the ecosystems to have a fully cycle supporting this, so not just the machine, is involve actually stakeholder in ecosystem HPC evolve a lot, okay? Because everybody have to link to have ecosystems. It will remain a challenge, a grand challenge for ASEAN regions. And in other regions as well, more or less than others. But hopefully there will be utopia somewhere. If there is one, I would like to have a recipe for that one. Last, as a service provider, I think in terms of human capacity in the school, we're talking about this to make use of this HPC growing, and we have pretty much we are oriented to the user, make application, make impact value to the people around you. I believe we might have to be worried a little bit about the group of people who being HPC operators and might be involved as what you would say, maybe HPC designers in the future. We might have big shortage of that one. Okay, that's my last words. Thank you.
Okay. So looking at you here, I see 80-something very brave souls, because as scientists, you've chosen a very challenging field. You need to understand the science. You're interested in life sciences, weather forecasting, etc. So you need to study hard to learn the science, to learn the physics, the chemistry, biology, etc. But then your tools to study are equally complicated. You need to understand, we have all these discussions about computer architecture, hardware design, GPU over CPU, all the new methods, AI versus statistics versus this or that. Then you also need to be very good programmers and to know how to implement your ideas and these algorithms. So indeed, I think it's very brave of you to venture into this field, because it's much more challenging than in other fields. Say if you are an experimentalist biologist, your instrument is an electron microscope or NMR machine. Yeah, it's not a simple machine, but yeah, you learn to use it, and it to some extent is like not a black box, but there is a manual, right? You press here, you get there, you press here, you get there. A microwave, you change the temperature and the duration, you get the experiment. But with computational science, you need to develop a lot more diverse skills, and this requires a lot more work. So I congratulate you on your choice of career. Don't be afraid. It will never be easy. So you will not run out of challenges to tackle. I can guarantee you that if it was really easy, you will get really bored. And I don't know what you will do. Well, we will just be on the beach and relaxing. So, yeah, so this is my fulfilling message to you.
Okay, so yeah. So then, yeah, I remind this situation. So I remind that when I work for the development Fugaku, so at that time, I was a program developer and I'm the biophysics, not HPC person. However, so I need to contact with the HPC architecture person, and at first I cannot understand what he's saying. What the guy is saying, even though he's speaking Japanese. Of course, my mother tongue is Japanese. What are you saying? Yeah. However, eventually, during the 6-7 years, I eventually understand what he is saying. However, even though finally I couldn't understand what they are thinking. Anyway, but so that I don't hesitate. I didn't hesitate to talk with them. yeah, then that is a more, yeah, I think that they think that they cannot understand me, of course, but try to understand and try to talk, it's quite important. So yeah, that is what I want to talk about. So that yeah, in this school, there is many countries and there is many scientific field and HPC person, architecture person, researcher, programmer, and so on. So then please, yeah, that is the end of the school. But so please keeping that touch each other. That's my message.
Well, we finished all the good stuff to say. I have nothing but to reiterate that pushing yourself outside the comfort zone is not easy. I experienced it in the other direction, coming from computer science background, and when I initially started interacting with domain experts. And domain experts means, chemists, biologists, no common language, and you're just speaking stuff I don't understand. And I would just tell them, just give me the code. And I would just, for me, just some instructions on how to code. That attitude didn't help me much because I pretty much plateaued very fast. And then I realized that the only way is to invest time and to consider it not just some code that will run, but I need to understand some of the, at least some sufficient enough knowledge to have a common language to speak. Numerical methods, what's happening. Also learn, meanwhile, I'm interested to know about different fields of science. I will ask them to the opposite. Don't look at supercomputing as a calculator, right? If you have this mindset, you will not go far beyond the tools given to you, right? And you will stagnate really fast. And somebody who's willing to put the effort and see it not just as a calculator, but an integral part, it's a scientific instrument. So again, a supercomputer is a scientific instrument. It's not just something for crunching, not a big calculator, right? Just like if high energy physics people are using large hadron collider or large particle accelerators, have to understand and even design it and get in depth into it, even though they're just high energy physicists, to get some stuff out of it, to understand it and use it. It's the same. Just treat it as a scientific instrument. It's not easy, but it pays off on the long term. And probably that's more or less what you guys said.
Okay, that's very good, very interesting. I mean, he went as I was hoping he could go. So, but let me get the panel to a closure. We still have 7 minutes, so we're not stressed. So, but first of all, thank you all because we've been a great audience. You've asked smart questions. You are not shy to ask questions. Our panelists, I think they did a great job because they gave you a point of view from different angle, from the application, from system provider, let's say. Another thing is probably one of the most important underpinnings of school. So you bring the people as a lecturer coming from different angles in the common denominator of what is high performance computing offer you guys to do the best science that you can. And I think, if I have to draw some conclusion, is the multidisciplinarity of the school that really give you the most. First of all, they give you, inspiration, maybe to change the way in which you're starting your career. They give you a full, a full instruction set of what you have to do if you want to be successful. And, here we have 3 tracks, so we focus on 3 computational areas, earth science, emerging computing, life science, and also, of course, across the board, the computer science. So I think the interdisciplinarity is good. It's also good, the networking effect. You come from, I believe we once again have all the 10 ASEAN countries, which is very important. I mean, at your age, I was also going to school. I mean, I was in energy physics, so I went to a summer school as a student in computing for high energy physics, and I made friends with whom I maintained relations for many, many years, and that's very important. I mean, science is understanding the instrument, understanding the science, use mathematics, as Leslie has recommended, use mathematics to describe your problem. Publish, it's very important to publish, not just because you want to be more successful in a career. It's very, very important to really put in order your thinking, make sure that your thinking has no flaws. You publish, you see the result of the paper published, then you try to explain your papers in a conference, or if you are in academics, by teaching to your student, and that will give you the feedback that you are on the right track. So, with this recommendation, I hope you have appreciated the discussion. I mean, the school is not finished, we still have a few interesting subjects to take. And, well, what can I say? You know, best wishes with your future career, and stay in touch.
Thank you, Fabrizio, and thank you all the panelists. And this will conclude our panel about the future of HPC, and we would like to give a token of appreciation to some of you, because some of you are new. To Joe, Regina, and Fabrizio. Joe, camera ready? We need to change the background. Hey. And Regina? And to our advisor. And this school will not happen without him, Dr. Fabrizio Ganiati. And thank you for collecting us and contacting all the speakers. And finally, we can make it. Okay, thank you very much. And you can have your coffee break for another 30 minutes. And with some information from our school.
Hello everyone. So this is the last panel, and we have 30 minutes break after this industrial presentation from Lenovo, AMD, ANSYS, and AMD, Lenovo, and Schneider. Hope you still here because we will have closing ceremony after that. Just informal closing ceremony started at 5. And please fill the feedback which will be distributed to the student for our feedback to the first HPC school. Okay, let's meet 30 minutes from now. Thank you.
Good afternoon. Good afternoon. Okay, first of all, I would like to say thank you to Indonesian National Research and Innovation Agency for giving us the opportunity to support for this event. And then, I think this is important track according to Pak Rifki, where each of our IT vendors will give speech for their latest technology. And these four gentlemen coming from Lenovo, AMD, Schneider, and also Cat IT, which is the distributor of ANSYS in ASEAN. Okay, I would like to introduce the first presenter, which is from Lenovo. By the way, my name is Lily. We are from Teknologika Utama, which is the IT system integrator in Indonesia. Okay, let me introduce the first presenter from Lenovo, which is Thomas Chai Chen Yuan. Correct? Currently, he is the Senior Sales Engineer Manager from Infrastructure Solution Group, Lenovo Enterprise Solution Ltd. He is flying from Malaysia to Indonesia yesterday. Thomas boasts 17 years experience in the technology industry, including 8 years at IBM, specializing in enterprise and HPC 86 solutions. His passion for continuous learning and knowledge sharing led him to Lenovo 9 years ago, where he thrives under industry leaders and actively engages with the community through speaking engagement and collaboration. Okay, without further ado, I give the slot to Thomas. Thomas, you're first.
Okay, thank you very much. Hey, good afternoon, everyone. Good afternoon. Oh. All right. Just a quick question. Standing here behind the table, is it okay? Or you guys want to meet outside? Is all right? All right. Okay. So today, thank you for inviting me down, and I just want to cover some few key points. Talk through where Lenovo is. Cover two of our key technologies when it comes to HPC, when it comes to our x86 solutions. So, a quick introduction to our vision. So I'm part of the ISG team. We are basically focused on being the most trusted partner for our customers, and we want to bring intelligent transformation using technology to really just drive transformation of their business, and of course to solve humanity's greatest challenges. The last point there, we are aiming to build supercomputers to solve problems, to predict weather, to find cure for cancer, to solve world hunger. So these are things that Lenovo aims to achieve. Now, don't worry about the details, because I just want to show you that, hey, Lenovo, we are investing in a lot of research and development. If you are familiar with the Lenovo brand, yes, we also have laptops, desktops, with mobile devices, we have servers, we have storage, we have solutions. We have a lot of different things, so we cover from client to edge to cloud, networking, intelligence. These are various research and development that we are putting money into. So we have a lot going on for us, and one of our best things I like to share these days is about our position in the top 500 supercomputers of the world. Now, Lenovo, we are the #1 vendor. We have sold, or we have built more supercomputers in the top 500 than anyone else. 169 of them is Lenovo branded. So more people buy from us, we build more supercomputers. So that's an achievement. In fact, for the past few years, we've been running #1 already in 2018 till now. And this is an achievement. Honestly, if you look at the chart, right, we started only in 2014. 2014, that is when, just to share, IBM sold me to Lenovo. So I was with IBM. Okay, overnight, hey, I'm in Lenovo. And then we started this journey, building our reputation. Building our reputation for x86 business, and we got there in 2018, and we kept climbing. So we are still #1, we're #1,
November 2023, the latest report, we are the #1 provider. Now, the latest report in November 2023. So, first and foremost, obviously, we retain #1 in terms of number of supercomputers deployed, and it's not including 2 supercomputers. One with Lenovo Fujitsu, the other one with Lenovo IBM. Okay, so the baseline for the entire list right now stands at about 2.015 petaflops. 45 systems turned over from June's report till now. Green 500, and I'll touch on this in a while. Green 500, Lenovo is #1. That is a relatively new list that positions the most energy efficient supercomputers of the world, and we are #1. And this supercomputer is based in Flatiron Institute. So #1 most energy efficient supercomputer is Lenovo branded. In fact, I'll share in a while as well. #10 is also Lenovo right now. So we are edging up. We are adding our solutions. We are showing that we know what we're doing. So, supercomputer Henry. So this is the supercomputer that is #1, top on the list in Flatiron Institute. So it achieved an energy efficiency of 65.40 gigaflops per watt. Okay, and with a HPL score of 2.88 petaflops per second. Okay, using Lenovo hardware, that's how we're able to drive 8,288 cores. And it's on the top 500, yes, it's not the most powerful or most fastest supercomputer, but these days more and more people are looking at energy efficiency. Governments are looking at energy efficiency. I mean, you can run to be the fastest supercomputer of the world, but you are spending way too much electricity, and the country's infrastructure cannot support you. What's going to happen there? So energy efficiency becomes so important that, hey, we have a new list called Green 500 to show who can build the most energy efficient supercomputers. Quick mention, #10 on the top Green 500 is actually in the Institute for Basic Sciences at South Korea. Also Lenovo is running on SR675V3, running AMD EPYC 9334. So these are things that we put in place, these that we are pushing forward to show value, to show that, hey, we can really provide what the customer wants. Of course, this year at Supercomputing 2023, we literally sweep the awards. We have lots and lots of awards, 9 awards more than anything we've received so far. All this covering like the top 5 lists, covering a number of other awards in terms of best use of HPC, top HPC enabled, etc. So these are awards to prove that we can do it. Of course, the obvious one is being the top vendor in top 500. That's the best. Okay, so these are things that we are bringing value to the table. So I want to change the slide pace to something else that's happened recently. So AMD, basically their CEO talked to my boss, and they talked about a few things about Lenovo and AMD working together. And effectively, the key messages here, and they generally talk about AI, talked about the MI300 and so on. But we talk about, hey, Lenovo, we are #3 AI infrastructure vendor of the world. Okay, IDC said that, not me, IDC. Okay, we are #3. Okay, we are providing AI from pocket to edge to cloud. That really just means that, hey, if you're not aware, Lenovo, we own a small little company called Motorola. Okay, mobile devices. So we have mobile devices, we have end user devices, we have server, we have edge servers. So literally Lenovo is the one vendor that can really provide end to end. Okay, from all the way from pocket to cloud. So we also announced another $1 billion investment into AI research and development. So we are looking to drive more AI. That is on top of our previous 1.2 billion that we already announced a few years back, and then now we're adding another 1 billion on top of that. Now on our portfolio, we have 70 AI-ready infrastructure, storage, and server infrastructure products. So we can build those AI solutions. We have an AI Innovators Program that have 65 ISVs talking about AI and their solutions out of 165 different solutions. And last but not least, on stage, my boss committed to say, hey, we're going to deliver an 8 GPU MI300X Think System Server. So we are committed, time to market. You'll see it as soon as possible. We're going to push it out when it's ready. Okay? Now, that will just bring to a full story that, hey, we have really all the various options, platforms, about the processors, accelerators, we have the processors, the mobile processors. End of the day, we are providing a fair range of solutions that you can really tap on. Now, I want to change gear, talk about two technologies. The first one is Lenovo Neptune. Anybody heard of Lenovo Neptune? It has to do with water. So, water cooling. Now, everyone is talking about net zero. So, Lenovo, we committed ourselves to reach net zero 2050. We'll have achieved net zero by 2050 with our targets validated and so on. And to reach that target, we've been putting a lot of technologies we're also offering to our customers. We're talking about energy management tools, we're talking about heat mitigation solutions, component selection, liquid cooling. And liquid cooling is the key solution here. Now, some may say, hey, my data center cannot do liquid cooling. Then how? It's starting to become not really an option that can I choose air cooling versus liquid cooling. So what I mean by that? So liquid cooling for Lenovo, we call it Lenovo Neptune. Okay, direct water cooling for your data centers. We optimize performance, yada yada yada. A bit of marketing slide, but this is our direct water cooling technology. And we are pushing this because of technology evolution. If you've been looking at various hardware, what's happening? CPU, 2014, we talked about for my processor, 145 watts. Today, my processor 500 watt. Same 1U space, I must put the same processor. It's more than double. And we talk about GPUs. From 250, now we're talking about 800 watts. DIMM memory, from 72 now, hey, your memory altogether adds up to about 600. Your adapters as well, moving up to 150, 10 times increase. And would you tell me, hey, with all this increase, I'm still going to use air cooling? Can it be done in the first place? So we have introduced a whole bunch of different technologies. That's liquid assisted cooling, there is direct water cooling. So liquid assisted cooling, basically we have like a thermal transfer module, we have liquid to air modules. And on the right, you see you will have direct water cooling, cooling straight into the core, cooling straight for every component. These are Neptune technology driving these energy efficiency requirements. And this is smarter engineering, which basically positions us to be able to drive much better energy efficiency. So if you're talking about using just air, you need a lot of air to push through. That means your fan will need to spin faster, need to push the air faster. The overall air conditioning, from last time maybe you say like 35 degrees, okay. Now it's you must have 25 or even lower. So these are things that's driving the changes. These are things that help reduce your electricity consumption. Now just a simple comparison. From the left, we talk about your standard heatsink. I can support like around CPU 250 watts. Okay, X-ray A2 35. Okay, very happy. 35 degrees ambient is the highest we can go. Then we move on to water assisted. So we have things like thermal transfer module, cooling the heat from the CPU to the front of the servers using water liquid. Okay, so that is one step forward, make it more efficient. You can push CPUs of 350 watts with X-ray rating of H1, your ambient temperature maximum of 25 degrees. But then we talk about liquid air module, say 350 watts, but then you can have 35 degrees ambient temperature. Last but not least, direct water cooling. Pulling the water straight in, touching the CPU, touching the memory, touching the adapters, and pulling all the heat out through the second pipe. So that you can actually run at 25% ambient max. It is rated at actually A2 and W45. So these are ratings that will allow you to get good PUE. So PUE is another thing that some people usually talk about. We talk about efficiencies. You go to certain, there's certain governments, the regulations state that how much PUE your data center is allowed, how high it can go. Lower is better. The more nearer to 1, the more efficient your energy consumption is. So the best is at 1.2 if you are setting up the direct water cooling. Now, of course, it comes to the point that says, hey, not every data center is ready for water. So we have a mix of all the different solutions, try to optimize the best that we can. But if you're talking about the fastest supercomputers of the world, and you consider how much heat it produces, then you really consider, hey, you have to come to a point where you are starting to look at water cooling. An actual data center that we worked out, there's a few numbers that you can see here. Effectively, if you talk about air cooling, your PUE, your efficiency rating is about 2.0 to 1.5. Whereas if you go air cooling with our rear door heat exchanger, now that is literally converting the single rack into a fridge. You have the back door, and there's water going through the back door to cool down the hot air as it comes out of the rack. And that gives you a PUE of about 1.4 to 1.2. Now, if you implement our direct water cooling, I know just now one of the earlier charts showed 1.2, right? The data center we did actually managed to achieve 1.1. Now, that is a very, very good result. That's what about in terms of energy efficiency and talking about saving electricity. This is the hardware that we use to achieve these good numbers. So we're talking about our SD models, SD665 V3 and the 665N V3 as well. So these are our key solutions. We're talking about supercomputers, talking about high energy efficiency. Now, the other technology I just want to touch. We recently announced this because Ghost is one of our key solutions. We're talking about genomics. And in the end of the day, we're talking about having a tool to really drive real value for our customers. Now, in genomics, what's happening there? The costs are declining. And we have people looking more, I want to do whole genome sequencing. So more and more people are going to do this sequencing, I'm going to draw more data, I'm going to do more research and development. Okay, they are looking to double their production every year. You'll be everywhere, it's pervasive, customized healthcare, literally your doctor, next time you see, check your genome, or you have this particular gene, that means you're more likely to have this particular illness, you should eat this particular vitamin, and so on. Very extremely customized healthcare based your DNA. So that allows us to really help and improve healthcare overall. Now, so what's happening in that space? We're talking about running genomics workflows. It is slow, it is complex, it is taking 60 to 150 hours for a single whole genome sequencing. So that is how slow, how long it can take. It is not scalable at the moment. A lot of people lack the expertise and the HPC knowledge to really optimize the overall solution. Now, one of the things that we have introduced is what we call Ghost. Not the one that goes, ooh, okay. Not that goes, GOAST. Okay, Genomics Optimization and Scalability Tool. This is, to simplify, it's a server, but it's optimized. Specific server, configured, set up to run genomics workloads. Now, one of our customers, we have already have selling this for quite a while. In fact, right now, I'm talking about this because we just launched version 4. Okay, the latest version of Ghost. In Spain, Barcelona Supercomputer Center, case study we did for them, their feedback is 40 hours Move from 40 hours, now they take 45 minutes. Imagine you are a researcher, you sit there, you click, let me come back 3 days later to get the results. Versus now, we put our goals in, let me click, I go drink coffee, and I come back and look at the results. Okay, that is how fast. That's the kind of improvement we're looking at. So the latest version is running on AMD. We moved from 3.1 to 4. Earlier on, we are talking about per sample, whole genome sequencing, 68 minutes. Every day you can do like 21.1. We have moved now to 24 minutes. Even better, even faster, more genomes being sequenced. So the performance is there. The enrichment, saving hours of their time. Some of them, the earlier use case I forgot to mention, they did from like previously they did 2 years. If they have put in the GHOST class, our best solution, they will only take 6 months. That's the speed that we're looking at. So GHOST is a fully optimized solution to run these genome workbooks. Okay, so this is just a quick show of the performance. On performance from my friendly competitors, 11.7 all the way down to 0.4 hours. That is savings. And we talk to researchers, developers, they go, yes, I want this. They will not say, hey, let me think about it. What's the price? What's the cost of hours? For a researcher, for 2 years, you drop to 6 months. You research something, it take 2 years, versus you do something and take 6 months. There's no value. It's priceless. That is priceless to just say, hey, I'm going to save 4 times faster. Okay? So, that's all I have. I just want to mention quick few points. Lenovo, we have enterprise innovation centers around the world, 4 of them to be exact. Usually any projects or any discussions, if you need to tap on us, we can actually grab our experts around the world. We have deployed in multiple countries. Based on the earlier chart, 169 supercomputers of the world is across around 19 markets that we actually are present and we are leading with our solutions. Okay, so that's all I have. Any questions? Questions will come later. I'll pass the mic to the next person. Thank you.
Okay, thank you, Thomas. Okay, so we come to the second presenter, which is coming from the Schneider. Schneider also play important role in the data center. The presenter will be Asep Supriyadi. He is the System and Architecture Engineer, ASEAN Zone Division, Schneider Electric International. He had data center expert certificate, responsibility to work closely with the country sales team and partners in designing and coordinating total solution for data centers according to customer needs and requirements. Asep Supriyadi has more than 22 years of experience in power, data center, and IT industry. Prior to joining Schneider Electric, Asep was a various distributor in SI for power, IT, and data center company. Also held technical manager position in the world largest distributor of IT products. Okay, please give time to Pak Asep.
Okay, thank you everybody. Good afternoon. Actually, my material is half of my material is already discussed by Thomas about the colleague. Okay, thank you very much. My name is Asep Supriyadi, as Google said, from Schneider Electric. Okay, so today I want to discuss about the technology evolution about the data center. So we discussed about the HPC in these 3 days, and then we have the novel AMD. But as Thomas said, HPC is do not can using the starter data center. So we as a starter data center company focus to how we can make the requirement for the data center. Okay. Schneider Electric is power management company. So don't ask me. We do not make a lift. Yeah, we do not make a escalator. Yeah, because every time the customer I say, from Schneider, oh, you make the lift. Yeah, no, we do not make that. Yeah, we doing the power management. So one of the division is my division, sure, power division is doing the data center. Okay, why Schneider is be the partner of data center? Number one is we do not just selling the product. We doing designing, building, operating, and maintenance. So we have a lot of data center, including me in my office. And then we building also, we operating also, and then we do maintenance also. That we do. And then also we make a lot of data center in Indonesia actually, and then all of the world. For the Schneider Electric, we is the biggest data center platform that we have. Usually the data center company is selling just part of the component because of data center have a lot of business units. So we have end-to-end product data center. So we have EV panel, transformer, we have UPS, we have sensor, bus duct for the best the side of the cable, and then we have lighting control, we have the chiller, containment system, power system, and in detail will be explained after this. At my division, the skill for division, we have UPS from the small one, 500 PA until 1.5 megawatt. So, and then we can parallel after 4.5 megawatt. So we have also cooling, precision cooling for data center. Also we have liquid cooling also for the HPC. And then don't ask me about the cooling for the bedroom. Yeah, we do not have that. Yeah. We just selling precision cooling for data center or for the utility room. And then we have a system of course to put the server to the network product. And then we have a product software here. I will explain this after this. And then we have the product center. And the last, it's quite proud and from Schneider because we have call center. The one and only data center company who have call center is Schneider. Our data center is not only big about the problem. So our customer care center is look like customer care center Lenovo or Samsung. So we have ticketing, we have order. So everybody there is no people who forget about the problem. Okay, we starting discuss about the data center evolution. Okay, actually there is a lot of development from the digitalization. When I very young, I write the letter to my girlfriend. No, there is no people who send again the letter yet. So everybody receive email on WhatsApp. Yeah. Okay, and then everything. There is the smartphone. Everybody is do not want to write anymore. Gen Z is very people who want to everything to be start. If you play the game, you must be online game. Yeah. If you buy something in the Tokopedia or Shopee, you must after you post buy, you must buy. If no, you can check the other application. This is the digitalization. So now the other sample is if you go to the McDonald's, there is no people anymore to handle you. You must talk to the robot. Yeah? Because of that, everything is now need data center. So before we do not need data center, now we have must data center. Okay, because of that, everything is must be cloud. yeah, but there is any problem with the cloud. So the cloud problem is, number one is latency. Yeah. Before, only for the email, if I send now 10 minutes, it's okay. But now, if I doing game, who doing the Mobile Legend here? Who? In Indonesia, everybody doing Mobile Legend. Why in here? Okay. Because everybody here is engineer, so don't have any time for playing the game. Okay, fine. Maybe, or the moment usually Saga. Okay. Let's take Mobile Legend. If Laila shooting Balkon Legend, if there is delay, this will be okay. Then the player will be by the other game. So latency is very important. Number two, bandwidth. Yeah. In my YouTube is whitening buffer is more longer than the YouTube player. Now we must the internet is very fast. Why? After this we discuss it. Energy security. Some of the company, some of the like banking, government is very concerned for the security. Not all of the data must be sent to the cloud. And then autonomy and interactivity. We do not put any hard disk, any memory there. Because of that, data center is not in the cloud anymore, and the local anymore. Now we said is hybridity. So will be there are data center in the edge, the nearest of the people, and then the regional edge and the centralized. Like YouTube, not only at the America, so it will be in Singapore. Also like Google, like Microsoft, also the other data center in Indonesia or Singapore for the hybrid. The edge, of course, everybody not need edge now. Because of that, Schneider have solution for the local edge, or regional edge, and for centralized. So we can make data center for only one rack with detailed data center, with cooling, with power, with monitoring system in the only one rack. Like for the hospital, like that. And then we can make data center for 3 to 4 rack, or we can make the whole data center for 100 and 1000 rack. So we can make every type of data center. Okay, what is our solution for our data center, including for the HPC? Number one, we have the electrical distribution. Yeah, we are the company, electrical company. We have medium voltage panel because when from the power plant come to the factory or to the home, usually is 4,000 volt. So we must be any medium voltage switch here, and then we have also medium voltage transformer. So we have low voltage breaker also, and then we have also UPS. UPS is very important for the data center. The two things, the important thing for data center is one is power, the other is cooling. Okay, the other our product is busbar. So HPC supercomputer is very high power. So if we use cable, it will be very huge cable over there. If we have 10 rack, we have 10 cable pull, but with the busbar, we just put one busbar and then all of the power will plug in the top of the rack. The other cooling, actually Thomas already explained it for the HPC. So for the cooling, we have air cool. If the power is not more than 4 kilowatt, standard cooling is okay in one rack. If more than 4 rack, we must using containment system. We must have supplement cooling using intercooling. But if more than 10, more than 20, we must using liquid cooling. So Schneider have a lot of type of the solution for the cooling. So if you have a 4 kilowatt per rack standard, you can use the air cool standard. If more than that, you can use the containment system to make higher capacity in each rack. If more than that, we can use liquid cooling. Also we have. Okay, and then we also make the white space infrastructure. We have server rack with every type of server rack. We have closed rack, we have open rack, we have two post rack or post rack. We have small. In the trend now is edge, yeah, local edge. So in every area is only need one server, that's including storage network, yeah, cover converts. So we have not only XTU, but you can put the rack in the side of the table. And then we have containment system. Also, we have all of the accessories of the rack server. So we have rack mount transfer switch, ATS. We have our distribution unit. Our distribution unit is also have the switching, have the monitoring. You can turn and turn off the video. And then we also have the access rack. So the rack server will be can accommodate by the RFID card, or there can be the part of the RFID. The other is we have prefabricated modular data center. So if the area is do not have place to make a data center, because usually in the government area is do not need a data center, but now because of the digital transformation is the data center. The problem is the building is do not decided to be a data center. The floor capacity, the security, and other is do not meet the data center standard. So we can make one of the container, like container, is there are a lot of rack there, complete with the rack, cooling, UPS, and all of the design data center. So we squeeze data center from the room to one container only. And then also the beauty of this product is we can move the data center to other place. Also we have for the operation, we have power operation, we have power monitoring export, we have building operation like building management system, yeah, like lift, like pump, like that. And then also we have power also. We have how big the data center power. And then we also we can measure with the power monitoring expert. And then for data center we have data center infrastructure management. Yeah, we have data center expert for the on-premise. We have IT expert for the cloud. So we have monitoring system on-premise and cloud. Also, we have IT advisor. IT advisor is analytic software. So if you have like 100 rack server, if you want to put one server like what level type of server? X. Okay. For the example, we want to put one server. Lenovo, you can just put it the name, and then the system will choose which rack is available from the cooling, from the power, from the load of the rack. So there is no activity who do not save. So if you plug the power, it will be saved. The other we have services. So that I mentioned before. We do not just selling the product, we do the designing, we do the implementing, we do the maintenance, and we do it. Okay, and the other, it is the last, I think, the last my slide. If the customer have already the data center is already passed out, maybe the PS is too old, or the space is too small, we do the modernization. We can discuss how we retiring the data center and find the new data center. Okay, that is from me. Thank you very much. My time, I back to Bu Lili.
Okay, thank you, Pak Asep. Okay, let's come to the presenter. If you have any question, please keep and write it down first, and then we will have another session question and answer after all the presentation finished. Okay, let's come to the presenter, which is Brando. Brando coming from IMD, and he has an Indonesian country commercial business lead from advanced micro devices. Brando Lubis is responsible for the commercial business in Indonesia as a commercial lead. As an advocate of AMD innovation, he strives to bring AMD value propositions in solving most important challenges by sharing best practices in HPC or AI, government, telco, enterprise, SMB channels with OEMs, customers, and partners. Brando has more than 11 years of experience in the IT industry, and prior joining AMD, he was with Fujitsu, Asus, and he holds a Bachelor of Information Technology, also postgraduate in Strategic Management. He is currently based in AMD office Jakarta, Indonesia. Okay, Brando, your turn.
Thank you, Bu Lili. Okay, good afternoon, all of you. So, my name is Rando. I want to share about AMD. AMD is a core technology for CPU, GPU, and accelerator. So, I just want give some awareness to you, to all of you guys, that what we are doing in the daily life, in our daily activity. So basically, we are for AMD is starting from 69, and we are the company who developed for 60 byte x86 60 byte 64 byte, and now we are many innovation that we are built with our technology. And as now that we develop Ryzen AI, now is GPU for MI300 that we develop with our R&D. And what we do is every AMD computing is already powered in daily life by billions. Why? Because in cloud, we are working on with Google Cloud, with AWS, Azure, Alibaba, Tencent, and then in 5G or telco industry, we also our technology deployed there in artificial intelligence as well, and then in adaptable intelligence system the most iconic is Tesla is one of our customer who using our technology, and in gaming and simulation maybe majority people know about our technology AP radio, and then in smarter client device it is laptop, desktop, or workstation, and in gaming console PlayStation 5, Xbox, that they using our technology. So our technology is in CPU, GPU, FPGA, and smart NIC. So this is we are focusing on core technology. So what we do is we are working on with many alliance. One of them is Lenovo. So I want to share some. I want to share a video that what we do in daily life. So in the supercomputer itself, like at scale for data center AI, that as now that what we develop, like one of them is like Frontier. Frontier is like top 500 like supercomputer right now. It's like still #1. And also we also develop a collaboration with Lumi and Microsoft Azure, Korean LLM, and many like industry, many supercomputer that we are already working on. And our CPU technology journey is start from 2017, so it is now maybe like around 6 years. So when we start this technology, that we improve like our technology very significant. As now in 2023, that we developed 3 models technology like using an epic Genoa, Bergamo Genoa X, and Sienna. So what is the difference? Like Genoa itself, like they have per CPU is using 96 core with PCIe 5.0 and 12 DDR channel, and with design is 5 nanometer. And also in Core Native that we have like CPU using 128 cores. So this is also using PCIe 5.0 and 12 DDR channel. I give some comparison with our previous technology, like our AMD EPIC before, like Gen 3, compared to our Gen 4 right now. Like in cloud, like the performance is like higher until like 80%. In HPC itself, like 92%, and in enterprise is like 80%. And if we compare to our competitor, this is like a good slide, like this is like some summaries. In performance leadership, like for density leadership, and then performance forwards for leadership, like AMD is like the performance is like 80% for using spec rate, and then for interference performance is 90%. And in terms of like price, like our price is very competitive. And then if we're talking about energy efficiency leadership, like we can saving like almost 80% if using our technology. So this is like benefit that what AMD offer in this industry. So in vertical industry, that what we do in manufacturing, media entertainment, energy, and then financial services, weather, life science, and telco. So we are working on how to speed up, how to make it efficient with our technology. This is like our AMD EPIC technology. And the second that I think Thomas mentioned before, that 6 December last week, that we are like launching our new product is MI300E and MI300X. This is like the good one, like GPU server, like the MI300A, it is like APU, Accelerated Processing Unit. It is like CPU and GPU combined. So it is like chip with 24 core CPU, and heavier memory is 128 GB. And MI300X itself, like the memory is 192 GB. One of the MI300 that what we do is like for supercomputer El Capitan, that it is start deployed from 5 July, this year. And we expected in late of 2023 that it is launching the technology. It is already using MI300, and this is like one of the most powerful supercomputer for HPC and AI. And the instinct itself, like as I mentioned, that this is like they have HPE memory is 192 gigabyte. So like what we do is like we try to give some alternative with our technology. So I have some like comparison versus our competition right now. So you can see like MI300 GPU compare like NVIDIA here, like with compare like the advantage with our technology from memory capacity, memory bandwidth. In HPC performance, like we have like performance is like 40% better, 140% better, and then in AI performance like 30% better. And inference advantage also like from competition that we just need less GPU to do like inference advantage with our technology. And second, with our APU MI300 accelerate processing unit, so it is combined between CPU and GPU. So what we do is like before our third generation is like it is like we have like CPU and we have GPU. So they have like shared memory, but now with our fourth generation that we are using unified memory. So what is the benefit using like this technology? When we compare with our competition, also like the performance is like equivalent with NVIDIA X100 XM, and the benefit is like the advantage is this is like unified memory, cell and infinite just technology, and dynamic power sharing, and easy programming. Like the example is like when you're using OpenVOM, like when we combine a unified memory bandwidth, and GPU performance, then MI300A is like 4 times better. When we are using like for big HPC performance, like with Grasshopper 200, like the performance is twice better. And HPV performance leadership for mini and body HPC and GROMAX, that the performance is almost equivalent. And the second is like AMD Instinct itself, MI300, it is running on open source. We call it ragam, AMD ragam. It is like open source. So this is like software that AMD developed that without cost. So this is open source. And we build like our GPU, then we have like library under ragam, a compiler and runtimes, and then for software like Python running there, TensorFlow, Hugging Face, and etc. So this is like what we do is we trying to build an ecosystem. So that's why like from us, from AMD, like I want to share it to everybody. You guys, like this is like one of like open source ecosystem that AMD developed, and the benefit is like when we do is this ecosystem, that the performance of AI itself is become increases. Related for sustainability with our technology, that we already doing like 30 times better with our gold standard for sustainability, for cost efficient, power efficiency. We can see from comparison here. So I give like some comparison for using 160,000 ANSYS fluent jobs per day. We compare with 30 cores using Intel and 30 cores using AMD EPIC. So what you do is like you just like using only like 12 server using AMD EPIC Gen 1. So this is like one of like the example that how we like saving like from fewer server, less power and annual cost saving. So that's why like we are consider with our like sustainability with our technology. Even though that in BRIN 500 is like the supercomputer that AMD developed is like we are also here in Frontier also number 2, adalah is like number 3 and etc. etc. And the ecosystem itself like we are open ecosystem. So we are not exclusive. So we are open to all for all brand, for the software, for the alliance. So AMD is open to any alliance in the world. So this is like our solution for HPC and AI. And the 3 points that what I want to share is like our software is open software, and then it is like proven technology, and the technology is like we are ready for support for science, for academic, and all the industry. Thank you.
Okay, all presenters shout on time. 2020, the last one. Okay, coming from CAT IT, they are the INSYS distributor in Asia. The presenter name is Reza Murama, Master of Science. He right now his position is Technical Sales Manager for Indonesia for CAT IT Consultant Asia PTE Ltd. And he has 10 years of experience in computational fluid dynamics or CFD using ANSYS and COMSOL. He has been consistently introducing CAE with CAT IT and ANSYS to Indonesia academic and industrial sectors for over 7 years. He also actively participates in the community by giving lectures on innovation, modeling, and numerical design. Okay, time is yours, Pak.
Okay, thank you very much. Good afternoon. Assalamualaikum warahmatullahi wabarakatuh. Okay, my name is Reza Rahman. I'm with CAT IT Consultants. I'm introducing software ANSYS. Yeah, my topic is ANSYS HPC solution for research and engineering purposes. Actually, I'm a bit different with other speakers. Talking about the hardware, this is I'm talking about software. So I apologize if some rooming about engineering terms. Okay. I'm introducing my company first. Okay. CAT IT is a leading engineering software distributor, system integrator, and also manufacturer. So we have manufacturer also. We start in 1991, and also we have 14 global offices with automotive lightning factory. So in ASEAN, Indonesia, Singapore, Malaysia, we have office there. So we have colleague there also to communicate regarding application of ANSYS. So if you maybe from Philippines wanted to ask about ANSYS, you can ask me first. I can connect with my colleague there. Okay. And we have 200 global technical staff strength with certificate expertise and with deep domain expertise in simulation and industry 4.0. So our business in Indonesia, we have ANSYS as a CAE, computational aided engineering, and also IoT development. But right now I introduce only for computational aided engineering or ANSYS software. Okay, we claim ANSYS is number one simulation engineering. Okay, our DNA is engineering simulation, and we invest heavily in research and development and acquisition of physics software simulation. And we have a global team of 5,100 employees, including me, accounted as an Indonesian representative for ANSYS. And we focus in the in the comprehensive simulation capability in industries. So our sector industries covered is we can say aerodynamic, aerospace, automotive, energy, healthcare, and our solution is related with the future technologies like autonomous electrification, 5G, IoT, something like that. But our solution, our software, divided our product divided based on physics-based simulation. So we have simulation for structures, fluid, we call it CFD, electronics, semiconductor, optical, 3D design, and photonics. Okay. Why using ANSYS and why with SPC? Because we want to get more design variation. So ANSYS is already is the industrial made. So it's already made for customer who don't want to do much in the development or code. So it's already code ready and compliant with standard. So we want to do more design variation. So in terms of faster, in terms of time, and then more design analyze, and then we can do optimization and robust design and improve productivity. So and then the second thing is a more accurate product data. We can call it high fidelity model. So we can say that accuracy is number one. We go accuracy better. And then we can say we do gold standard modeling, so accuracy like 80% more. We usually achieve it to model it. And then do the detailed geometry and full assemblies. So why ANSYS? Because it's easy, focused in innovation, faster in time to market, less rework, and standard compliance. Okay. And here's the thing. Top 50 HPC applications that use in HPC. There is a board for ANSYS Fluent, ANSYS Mechanical, LSTC, and ANSYS LS Dyna, and ANSYS AFX. And top of 20, so ANSYS software is using together with HPC. So ANSYS is supported by HPC mode. And if we check in Google or in publication, that ANSYS and HPC has a lot of publication. So we can not only just talking about the usage or the usage, but also for research mode. And this is some example that maybe I can show. So there is MRI, modeling, free flow, and then your process pretest study. Okay. If we use ANSYS Mechanical and ANSYS HPC, we can do the magnetic resonance imaging (MRI). So it's reliant with compliance, and ANSYS also one of developers that introduced in silico method. So there is a quote below that the use in silico computational modeling has provided a novel and efficient approach for assessing MRI patients safely and improving information to clinicians. So the next example is actually this is a model, simple model. I don't do the very big model. This is a simple model that I can show. I built within 1 week. Okay. So this is a fluid analysis for flood model. I don't want to say tsunami because it's only so small model. So it's we can see the behavior of fluid there and the contact between fluid to the structure. So the left hand side is fluid profile, and then below is the pressure and the stress in the structure. And then the right hand side is pollution model. Actually, this in coincidence regarding the president debate candidate this week, right? Is talking about Jakarta pollution, something like that. So actually, in ANSYS we can do also the pollution modeling with the CO2 mass fraction inside of that, and then we see the wind where it's going in, something like that. So if the two presidents talking about the pollution, let's check the ANSYS. Okay, whether it's from car or from the power plant generation. Okay, the last is one of the benchmark for mechanical. This is a benchmark. This is a big work potential study. So large assembly and require 1.2 million nodes. And using this hardware, HP Gen 7 volt, okay, with performance that. So and using almost 1,000 SPs cores that open by ANSYS. And if we compare with or without HPC, we can get the speed up like 4.5 speed up. So if without HPC, we run almost like 50 hours, and with HPC it's 10 hours. And then not only that fluid, but also HPC dynamic phenomena that related with the crash or impact. Okay. So this is crashworthiness analysis. So if we see that we don't have to do the physical testing that you crash your car many times physically and it will cost you. So we can do crash analysis virtually like this, and this comply with the standard. And then this is the left one is before using ANSYS LS Dyna, and you can see that the dotted is really straight, and then the right hand side is the dot or test of variance is almost in the same spot. Okay, and then another thing is blast. So you can model the blast, whether you design a bunker for the set your A1 assets like president, prime minister, or you can do the after effect, like say there is a terrorist bomb, something like that, and then there is the area that polished by bomb, and then we need to investigate how many tons the bomb, something like that. And then we can do the cardiovascular stent. This is in silico also, so we can do the analysis for the stent. So we have a long pipe like that, and then the stent can be expanded. So why using ANSYS? Because we have material that is safe for it's not toxic, and we have the data material there, and also we can manage the phenomena that it will be make bleeding or not, something like that. And at the end, also it can reduce the cost of physical testing about 10%. And then there is SPC for electronics and photonics. This is for battery. So for battery, we can for battery is electric motor. So we can do trial and error in this virtual before we manufacture. And also application for IC. So ANSYS Electronic Enterprise can help you to design. If you design the chip, okay, there is a lot of unknown situation like impedance, scattering, and something like that. So ANSYS can help to solve at least 100 million plus unknown area that you can see in simulation. And then the last one is photonics. So the photonics is ANSYS numerical can help for photonic integrated circuit. If we say internet integrated circuit, and then there is a new technologies for photonics integrated circuit. So ANSYS numerical can help you to design before you model it. And this is some example in Indonesia. So regarding ANSYS for water management, we can do a floating model just of water, or include with the soil and sedimentation. So we can do that. And the real case there in Indonesia that we Two is some effort in the power generator then for CFD and the structural analysis. And we just not talk about the ANSYS itself. So if we, because of I'm from IT as a partner, so we not only focus in the CAA simulation, but if we focus with digital twin, is together if we mix CAA with the real-time sensors IoT and then with the ML machine learning, we can reach the big accuracy is 95% accuracy for hybrid digital tool. And maybe that we can offer that how that IT can help the customer, because this is one of our product that already implemented in one of our customer, that we have a real data from sensor like adapter speed, mass flow rate, liquid, circular hydro, liquid temperature, and outlet temperature. This is can be detected by sensor, but mixing index is only can be shown from simulation, and we have another sensor that only can get from simulation. Not only mixing index, but also like corrosion rate, something like that. So if you have any question, don't hesitate to contact me. My name is Reza Nur Rahman. Thank you very much.
Thank you, Reza. Okay, we will open session question and answer. If you have question for all gentlemen over here, please. We open. Siapa dulu? Ayo, again, please. Aku nggak boleh rebutan, Pak.
Thank you very much. My question will be for Thomas. So we have a course actually already in our SPC BRIN, but I'm asking about what kind of analysis that we can do with the course. You mentioned that we can accelerate from 40 hours to 45 minutes with the data. WGS means whole genome sequencing, right? Is it?
Yeah, okay, I'm adding the last questions. I want to ask the same question to Lina, but I think this is not question but request. Because in 2022, BRIN procures tools, and we have sequencing lab in different buildings. And in this year, we propose facilitation of sequencing of the many samples in so what I want to request from the is technical assistance about the implementations of the course to support the sequencing lab category. Because right now it's still disconnect between the activities in the sequencing lab and in the HPC servers. So maybe you can advise us how to implement this system to deal with the many samples. For example, we would like to sequencing whole sequence of the animals or plants and also human.
I think this is a very complex answer. so in a sense, I would say right now, I don't have a straightforward answer for you. What we can do, we can sit down, we can get our experts that covers the goal solution to really go through what we've done so far and how we've helped certain customers and use cases. And I am picturing more that, hey, we can actually do some studies in terms of what are the specific use cases you're looking at, and then the experts will be able to advise that, yeah, to reach those requirements, we can offer this and so on to really integrate everything together. So offhand, I don't have a straightforward answer. It's not so straightforward, but we definitely have the resources. We have the folks with the experts. Yeah. In fact, when we developed this solution, it was based on an expert from that particular line of this profession that they helped us to understand and we helped to optimize the overall solution. First, we came up with the ghost solution to help.
Okay.
Yeah. Let's talk more later. Yes. Bobby will love to talk to you. The team will love to talk to you. Sorry, I know, sir. We'll get the rest. Yes.
I should contact.
Nanti kita akan arrange, so we will arrange back for the first one because it's only haven't implemented yet. So I will try to arrange with also the regional teams.
Okay.
Just Ananda. We will. Sure. Thank you. Any other questions for these four gentlemen? Not only Lenovo, we also have AMD, Snyder, and also ANSYS guy, the distributor ANSYS.
Hi. Yeah, I would like to ask for ANSYS. Yeah. In my university, I got a license for ANSYS, but it comes with a PC and the software come together. But for me, if I would like to move my code to run on HPC, is that possible? Like take my code to run on Fugaku, is that possible to transfer? Because when I use ANSYS in the PC, that there's a hard lock. So is that possible to move to run on another PC? So with this, in this case, is that possible? Yeah.
Okay, let me. Actually, I'm not the one who can answer that, but I'm trying to explain you regarding the licensing. Okay, so license ANSYS that you install in your machine is mostly LAN-based license. So it cannot be moved except you can request to your vendor move to other PCs, something like that. If you want to move, you bring your own license to other PC that maybe abroad, like Japan or somewhere else. So you need to request specially to the vendor that I want to use my own license in this machine in Japan, let's say like that. So they will help you to generate the borrow license. You can say like that. So you can try that.
Answer the question already? You answer the question already? Okay, thank you. Okay, any other questions? We still have about 10 minutes or 5 minutes. Any other questions? No? Okay, so thank you so much everyone here. Thank you for supporting for this event. And give applause to all the presenters. Thank you. If you have problem question, we also waiting outside. So, okay, kita will give it to Pak Ip or Pak Andrea.
Okay, thank you, Bu Lili. And we would like to give you token of appreciations from our school director, Sedikit. Start from Thomas. ANSYS first. Thank you for your support for our HPC school.
ASEAN HPC school to our. And the second one to. Okay, anyway. To.
Yeah, Reza from Snyder ya Pak ya. From Snyder. Oh, Asep ya.
Pak Asep from Snyder. Sophie first. Okay. One, two, three, camera ready. Thank you. And the third one to Brandon F. AMD from Brandon from AMD. Thank you for your support. Next one is for Thomas from Lenovo. Thank you, Thomas. Thank you.
Belum.
One, two, three. And to Bu Lili from Teknologika. And make sure that you already fill out the feedback form from BRIN and from the other one that shown with QR code outside to make sure that you haven't changed to win Xbox. Yeah. Okay. Thank you. Hopefully it will repeat. Okay, thank you. And now we come to the end of our HPC school with the closing ceremony from it's closing ceremony. And the closing ceremony, please. And thank you for your support. And we know last information about the HPC. No, I don't want to be still. This is how it is here. And the closing ceremony will be, we need feedback from you, even though you already fill out the feedback form. And yeah, 2 forms already. And one of those will be, you will have a chance to win an Xbox, and the other one you will get a chance to get a thank you from us. And yeah, but nevertheless, you need to also give your comments, anything you want to say to our school director, not from me, to him. And who? Okay. Anyway, at least I want to have three participants from each track, one from each track, to give a comments about the program, your anything you want to say about this HPC school, so we know what to improve and what can we expect. Anyway, okay, from track 1, life science, who want to give comments? 1, 2, 3, or otherwise I will make a random number generator in my head and then point without someone. Okay, that's good.
Hi.
So the camera can see your face, and we can remember you. So.
Hi, I'm Naiheng from Singapore. This is my second year in the HPC school, and I'm in the life science track. I feel that compared to last year, some of the presenters, the program that they introduced, they improved a lot. Able to learn more about terms, and also there are more variety, like for example, Prof. Supa from Kaseswat University. I learned about QM is something that I always wanted to learn. Okay, I'm not like too deep, but really it's from the bottom of my heart. I think activities are. I think generally the activities are quite nice. Indonesia's food is quite nice also, but it's a bit spicy for non-Indonesian. Then regarding just one last comment. I hope that my conversation or shower.
Stop me to say something. Anyway, that was intentionally because the weather is here is very hot. So we have shower with cold water to make our body feel relaxed. So thank you. And probably one more thing. If you want to attend the next HPC school, especially in your track web science, what do you expect to be included in the next HPC school?
As of now, I haven't thought about it. It's only 3 days, so we only have like 5 days to learn the stuff, and I feel that it's already quite rushed. Yeah, so I don't know if there's any chance for you all to add any new content.
Okay, thank you very much. Okay, next from the Argent Computing and Climate Science. Anyone would give a comment? She's from computer science, not from life. Anyone from me? Oh no. Okay. Anyone, please? By speaking here, probably you increase your chance to get an Xbox. Probably. I'm not saying that it makes sure that one, but probably with a little. Okay, you.
Okay, I am going to sing just like the one beside me. So in the parallel session of us, by the way, I'm Ed. You can call me Eduardo. I'm from the Philippines. I'm doing research in AI model development, so in projects related to AI. So in relate to the session on urgent climate modeling and urgent forget the session. So well, it was
computing and climate science.
Yeah, it was really interesting because I don't have a good background with climate modeling. It was very interesting to see the practice, current state of the arts, what are the current needs, what are the current challenges when it comes to climate modeling. And although maybe I wanted somehow hands-on on that, of course, given the limited time, we hope that I can also work on that for the next 3 months. So yeah, I think everyone enjoyed also the visualizations. So I think everyone in the session, have many ideas, earthquake modeling also. But of course, we are limited with the hardware, also with HPC and some other simulation algorithms, etc. Well, it's this part of the challenge research. I think one of the speakers mentioned that I think the first panel session that if it's not hard, it's not you're not going to be happy. No? So if there is no challenge, then you will not learn. I think that's what that session.
Okay, thank you very much. About the dormitory, do you have comment? About the dormitory, about the food?
That's fantastic.
Don't sugarcoat it. Do not sugarcoat anything. Okay, the next one is from computer science. Anyone want to be volunteer? No, she's not away. So, anyone else? No one?
Yang cewek lagi katanya.
No one? Give a comment to me? Or are you too afraid? The mathematician. Okay. Please introduce yourself and give the comments. Some comments.
My name is Eva, and I'm from Indonesia.
Closer.
Okay. Okay. My name is Eva, and I'm from Indonesia. Actually, at first I think that I'm wrong that I'm in the computer science track because.
Okay. Why?
At first. Yeah. At first, but because I think that in computer science we try to figure out how to maintenance the HPC and something like that. But in the end, I feel that I'm very grateful to be there because in the first day there is some exercise and it's really hard for me as a mathematician because that was the first time I learned about programming. I really want to learn that before I apply this HPC. I'm grateful that I met a lot of friends that really good at computer science, and actually there are a lot of background in computer science track. There are some physics, quantum physician, also someone who works on PNKG, also someone who works on nuclear science, and etc. So it is very interesting to join the computer science track because we have a lot of time to discuss our exercise, and then we get to be close to each other because of that exercise. And then for the next day, I'm really grateful that I can get a course from NVIDIA without payment. So thank you. And I'm really grateful that also the lecturer gave me a lot of things. I think after this school, I will like to explore more about this. Thank you very much.
Anyone want to give another comments before? Okay, where am I? We are waiting for you.
Good afternoon, everyone. I got a couple of things to confess. Because of this is my first time visiting in, and my second time visiting Indonesia. It has changed a lot, and I'm very glad. The first day when we entered to the dorm, It was scary because we
Scary? Yes, me too.
yeah, we all said that, well, let's have a camping. But it's been a memorable camping. Thank you. I have a lot of private discussion with the organizer about first there's no hot water, second there's no hair dryer, third there is no lunch available. Some of my friends went for praying and then they come back and there's no lunch.
Yes.
After that complaint, everything was put in the box.
Not because of you. That's because of you.
I'm sorry. Sorry for guys who are looking for porridge in the morning. Which has been put in the box. But of all, I also asked for medicine for some of our friends who got sick during the training. And the organizer was so amazing. They get the medicine and they come back and ask, do you want also vitamin C? I was so impressed. I got to a handkerchief from Thailand too. I think I'm the only one who joined EU ASEAN HPC school since the first time online in 2021 and been in Kazakhstan in 2022. And I managed to come here with my pocket money, but that's okay. That's worth it, really. I must tell you that every single year is a leap improvement in the technology. Tuaku on demand was not available last year, but this year is fully active. AI in life science was not available last year, and exercise in computer science item was far more difficult last year. The tools presenting in computer science section was different angle and give in-depth knowledge. I like to tell you that last year I got my student being able to win Best Performance Award because of what I learned from the school. But this year, 2023, we put more effort. We want to win the first prize. But what happened to us is we dropped down to marine place. Our competitors are very strong. I'm confident that my students' team were doing better, more in-depth, more analytic, using our performance to available. But we still number 7 in the whole rank of the APEC region. So ASEAN as a total region, yes, we are stronger together, but I would like to encourage you to keep the network stronger and stronger. Don't forget this time at BRIN. Don't forget the Indonesian yummy food. And of course, and better. And thank you for the time, for sharing all the experience. Thank you to E-Ready to start all of this. And thank you to Fabricio that you pass on your experience and make this school happen for us. And my whole heart thank you to BRIN. Thank you for all lecturers. Thank you for
Thank you. Okay,
Now I would like to give I will ask some of the comments from the lecturers who are still available here. 1, 2, 3, 4, 5. Probably one lecturer who wants to give comments. Please. Baron. Yeah.
Okay. Yeah, look, all tables away, nothing happens. Fabrizio invited me to come here, and as I've never been in that region, and I like to explore new regions, cultures, food, or something, I immediately said yes. But I have to admit, I was a little bit worried. Yeah, I said, oh, Indonesia, I don't know what to expect. There's 80 students coming, and then there's we want to use Fukaku, which is 5,000 kilometers away. Do we even have enough internet? If I do my exercises, but I have to admit, all of you blow me away. Yeah, the organizers did an amazing job. We had these really cool facilities. Everyone had a good seat. We had amazing internet. Everything worked. Everything was very nice. The food was very good. I avoid a little bit spicy things, but many of you helped me, so thank you very much. Also, I was a little bit afraid, perhaps, we have a harder time communicate, because for most of us, English is not the first language, but the second. But I have to tell you, I've been in many places, Latin America and others, but I never had so few problems to talk to people. Actually, I had no problems at all to all talk with you. You are amazing people. You all speak very good English. There was no problem communicating with you. So thank you very much. And you're really, really amazing students. And you were so engaged. You asked so many questions. It is also not always the case. Yeah, some people come here and say, "Oh, great! I'm here. I'm enjoying the food, and I'm going home." But no, you came to us. You ask questions, yeah. You also have to, I come here, do all the work, and then if people are sitting in the room and are not listening or saying, there's this guy from Germany or something, it's no fun, yeah. But with you guys, it was a lot of fun, yeah, and we had fun together, and so thank you very much. And the last thing I want to give a big thank you is to the people at RIKEN, because I think without this great Fukaku, all the time we invested, giving us the access and everything, the school would also not be as nice. So also I think a big thank you to RIKEN and their support. So I'm so happy I was here, and with a little luck, I don't know. I might be inclined if someone invites me again in the following year. I might be willing to come.
Okay. Thank you, Bert. Thank you, Bert. Okay. Fabrizio, do you want to give a comment? Because you advise us how to run this from the beginning, or from the very beginning, you contact most of the, not most, all of the lecturers. Yeah.
Well, that's very easy. You just need to grow old enough. And you have
okay, I have to wait for
another 50 years. Let me try to maybe compare this. So as I said in my intervention this morning, so we start with having a good contingent of ASEAN students attending the school that organized under the ASEAN auspices in Barcelona. And then we try to model the school here. And of course, the first year was complicated because of COVID. So we ran it virtual. It was a major effort because running a school virtual is not easy. But the ready team, Aldo, made a great job. And RIKEN really saved the day. because there was no way that we could run the school from Europe in the time zone which was decided to be the Bangkok time zone, which is the same as this year. So for Arthur and myself, it was a little bit stressful because we had to wake up every day at 3 a.m. to start the school at 4, but that was fun. And I think it was successful. So that encouraged the funding agency, everyone, to run the school in presence in Bangkok. And I must say, which was last year, if I compare Bangkok with the school, I mean, the quality of the student, very comparable. Excellent student there, excellent student here. With some of the students we have been kept in contact. I had the chance to meet some of the students that moved in the meantime to Europe, to Geneva. So I think, the school, I'd say, I'll put them on the same level, which is very good because, I mean, for me, I've been involved with so many schools, so it's not a big deal. A new school, I know everyone, people come because they're my friends, it's easy, and they are excited, like me, to teach the next generation of scientists. So we have a tremendous personal motivation. I'm speaking for myself, I'm speaking on behalf of all the other lecturers. But for the local organizer, it's the first time. So for Kaiser University in Bangkok was the first time we organized the school. Here, of course, we had the support, we had other people from here that were present, so they could get some ideas. But for them, it was the first time. It's an international school. It's all ASEAN country represented. There is the funding agency. There is the sponsor. It's not easy. So really, I would like to congratulate the local organizer. They've done a great job, and I hope that next year I will be able to congratulate somebody else, or you guys again, for yet another school. No further, I mean, everything is fine, and I think no particular comment. Just keep carry on.
Thank you for your efforts. I would like to give one more comment from friends from Fugaku, Georgie, or could you please give one of us? Because we can do nothing without your support, especially from Slack, and Fugaku access. Everything is run smoothly, so thank you for your support. Well, I'm a speaker, but I'm not a lecturer. As I explained in the first day, I work in the operational side, and my main work is user support. That is, from now until the end of the March, you'll be the Fugaku users. So if you have any problem until then, please don't hesitate to contact us, and we will be happy to help you as much as possible. I'm very, very happy to be here to participate in this HPC school. It is my second time, and hope you can take advantage of the use of the Fugaku, since I can say that even Japanese that they want to use Fugaku, they use the resource is so competitive, they need to submit the proposal. So you have this opportunity to use, so don't lose this opportunity. Okay? And now we would like to have a comment from the director of the school, and he also gives a closing remarks, and eventually he will give you your certificates. And probably he will announce who will get the expo. No, not yet. Anyway, the floor is yours.
Okay, thank you, Andrea. Andrea is is the vice rector for academics. Okay, good afternoon, everybody. So I'm representing BRIN right now because the top management now having top management meeting in another area. so nobody can come to close this meeting, and they asked me to close this school. In the name of the BRIN, I would like to say my grateful first to the LAD for the support, Mr. Aldo from the beginning, and also the staff of LAD. They are very helpful during the preparation of this school, to Ami, Maureen, and also Deacon, and here Mr. Georgie, and Ms. Professor Tibusak. Thank you for your help preparing the school and access to Fugaku. And other lecturers still here, Mr. Rosenberg and Professor Supa. Thank you for your coming for this school. And also in this week, we already having a school, and many students maybe just get exposures of the HPC. And I do hope that for the ASEAN countries can also in the home institution can also disseminate the HPC technology, so we can get more stronger to have more people working on the SPC or using SPC. And the last, I would like to very big thanks to the local organizers, because without them, this school may be not running well. First, I would like to thank who present here. This is my secretary, Rizka. Rizka handle all documents and always have a headache when I ask him Excel something. And then Bu Amida, Brenda. Bu Amida is Ministry of Secretary. Amida manages everything well, because I'm a little bit unstructured. Amida is structured person. Thank you, Amida. And then here, Bu Ina Sabarina. She actually taught us in managing, conducting lectures for life science, but also climate science. And then our dormitory chief, Pak Taufik Wirahman. So he is the master of the house. And then I thank also to the operators of Zoom and anything technical from Steffi. Now I think now he is the best operator. And Ihsan Nugraha, thank you. Thank you also the participant for live science, and before the tracks, those also the local also the participants are preparing seriously until midnight, preparing their materials. Isa, Maulida, where is Maulida? And Buratna. And then also Furkan is investing student. He is helping local organizers in many things. every moment he is it. And then who's Yuli Julie was helping us managing lecturers, sitting up the questions. This is Maurida. Ibnu. And the one who always in the registration, Aditya.
He is still in the registration.
Siapa lagi? Siapa yang belum? Aji, ya untuk Aji. Oh, sini. Oh yeah, I forgot. One from DMKG, also helping us as local organizer, Mr. Hanif. I also forget that he is from DMKG. So now I think we would like to invite some students to having certificate. Everyone will get certificate, don't worry. But this is only representing each country.
Okay, I would call Sohan Chen from Cambodia. Sohan. Fahrul Akbar from Indonesia. And Sudat Lam from Malaysia. Lei Heng Tan from Singapore. Murawan Dias Kalbaru, Thailand. And Rudaina Muhammad from the Philippines. Okay, and the last one, Lee Van Nguyen from Vietnam. And for the rest, there will be no certificate. No, sorry, no. You will get your certificate later. So, please continue.
So, I think I will officially close the school. in the name of the BRIN. So thank you for all. Thank you for students, lecturers, sponsors, and our supporters. I officially close this school. Thank you for But tomorrow we will have excursion and farewell dinner.
Yeah, farewell lunch for Botanical Garden, but you need to be prepared at 8 o'clock in the morning in front of Edelweiss dormitory, and we are going to go to our HPC outdoor room, and after that we're going to have an excursion in the Bogor Botanical Garden, and will be closed by farewell lunch at Plaza Restaurant. Yeah, Plaza Restaurant. Secret Garden. Okay, that's very secret. Yeah? Secret. Don't tell anyone. Okay. And okay, that's all for now. And take a rest. And by the way, if you we need to take another photo, group photo, in front of them. Okay, that's the most.
Because the background will be from
And for those who has flight in the morning or in the afternoon, and that's the excursion is optional. So if you need to catch your flight, so probably you need to prepare earlier. But for those who can join the excursion, you can also take your luggage to Bogor Botanical Garden and travel from Bogor Botanical Garden to the airport. It's easier than travel from here, Cibinong. And yeah, okay. Enjoy your night and take a rest. See you tomorrow.
Recording stopped.